In the year 2000, Awqaf South Africa was pioneered as an institute of Waqf and the empowerment of communities. South Africa faces a diverse set of challenges with a high unemployment rate and a stark divide between rich and poor, where electricity, hospital care and water shortages plague communities and where lack of education hinders progress. Awqaf South Africa is a catalyst for change. As a charitable endowment receiving organization, Awqaf invests endowment funds wisely and ensures that only the income generated from investments is used to fund a variety of community development projects. We are excelling in all that we do with the highest standards of ethics, integrity, and sincerity of purpose. From masjid development, imam empowerment to sports development, orphan support, food security, and surgery support, Awqaf South Africa is paving the way by investing in the future of communities and uplifting generations to come. Awqaf South Africa, creating a legacy of hope and
And that was the national anthem of the Republic of South Africa. I'm Khalid Kungani Kivaspadi. Welcome to Awqaf SA's Grade 11 Paper 2 Maths workshop that is going on here at South Peninsula High School in Plumstead, Cape Town. As I said that my name is Khalid Kungani Kivaspadi. We've got to run things very quickly today because Mr. Kota is on fire. If you are just joining us, do make sure that you tell others to stream live and to follow us on our Facebook as well as our YouTube pages, as we are busy trying to assist the students. Now, this workshop is both in conjunction with the Department of the Basic Education as well as iSkill and Thread Waqf. We had Imran Jiwa from Thread Waqf who was with here yesterday. Now I'd like to call Mr. Baker, who is the principal, the incumbent principal here at South Peninsula High School, who will be talking to us shortly for his ultimate address at this workshop. As you may know that Mr. Baker will be retiring, so we pray that Allah subhanahu wa ta'ala accept him as well as his efforts that he has put in 43 years here at South Peninsula High School. Mr. Baker, over to you.
Thank you. Thank you very much to you, students. Firstly, good morning to everybody. Dumelang, Shalom, Assalamu alaikum, Molo, Molweni, and that is to everyone in South Africa who are tuned in, who are live streaming the Awqaf South Africa Grade 11 workshop, preparation for your November examinations. Students, we are blessed to have Mohammed Kota with us, and it's also an honor for the school to host Mohammed Kota for day 2 of the 2024 Grade 11 preparation. Now, there's not much that we would want to say. It's good to see so many SP students here this morning. Yesterday, we had a good turnout also. That's a clear indication to me that you are on fire, that you are serious about wanting to do well in the Grade 11 November exams. And remember, students, those marks are the marks that you are going to use to apply to tertiary institutions next year. And I always say this to students: take control of your future and don't allow somebody else to do that for you. So students, we all know pure maths opens doors. And my experience talking to ex-students who are currently studying at the universities, they all come back to me and they say, "Sir, thank you for forcing us to do pure maths in grade 10 and grade 11. And yes, we know that there are few students at South Peninsula who switch from pure maths to mathematical literacy, but even those students who are doing law and some of the other programs at university would come back and say, "Sir, even the 2 years of pure maths helped us in understanding and also helped us with the course that we are doing." So students, we know that it's Euclidean geometry today, it's Trigs today, and when I speak to my matrics, they often moan about paper 2. So today you have Mohammed Kota, who will show you a few tips, maybe a few shortcuts, as far as the 2 sections of the work is concerned. Without further ado, I now hand over to the team who will take us through the program today. Thank you.
Thank you very much, Mr. Baker. And I think now it's time that we do launch that rocket. We're going to ask Romana, who is currently in our offices at Awqaf SA in Johannesburg, to do launch that rocket so that we can introduce Mr. Kota and he takes the workshop away.
T-15. 10, 9, 8, 7, 6, 5, 4, 3, 2. We have liftoff. Vehicle is pitching downrange.
for everybody that has come in. Welcome, welcome, welcome. I hope you guys enjoyed to see your bright faces on a Sunday morning eating your kusisters and coffee, and to see you guys all ready, fired up, fueled up to do mathematics paper 2. So I'm assuming, inshallah, that you had a fantastic day yesterday. I know you must have been broken yesterday, but we had a fantastic day. We had a little bit of comic relief throughout our program, kept us going. Remember, I said we one big family. And today is paper 2. And we're starting off with trigonometry, guys. I want to start off while your minds are fresh. I'm going to take 2 past papers from final exams from different provinces. Guys, if you've just joined us now, remember something. It's as if we are writing the final paper all together as one team. So I will think out the thought processes. I will explain to you step by step. How do we go about doing every single topic? Where there's shortcuts, where there's hacks, I'll show you how to do it. And I promise you, I hope that trigonometry and Euclidean are going to be the 2 topics you are actually going to be looking forward to when you write your final exam. Okay, so just a warm welcome to all the learners that are hitting us up. Kamogelo, Luandle, Tini, where's my friend Mashaba, Sandika, Petunia? Where's Mashaba? Is Mashaba in this morning? Let's check if Mashaba is in. Mukuba, Precious, Chekofatso, Moloko, Karabo. It sparkles. You are back. Good morning, everyone. We are back. Moloko, good morning, good morning, good morning to everybody. Unknown. Sternbergian, Peninsula South SP, we see you, Reese. Right, good morning, good morning, good morning. Everybody is nice and bright and fresh and early. Let's get cracking, guys. Let's get into our program. You know what you need for today. Let's see. You know what you need for today. So obviously, you need your writing material. You need your writing material, you need your hydration, you need your brain. The main thing is that you need your brain today. You need to concentrate. You need to listen to me. Mashaba is in the house. Mashaba is in the house. If Mashaba is here, I'm happy. Right. Good morning, everybody. Let's get started. I know everybody is a bit shaky, everybody's anxious, everybody's nervous for paper 2, but relax, we got you. Paper 2 is easy. Data handling is easy. Analytics, you're going to get 2 questions. That's easy. That's basically midpoint, parallel lines, perpendicular lines. That's easy. Trigonometry hits you a bit, but I'm going to show you how easy and how nice is it to do today. We're starting with that now. And then you got Euclidean. And there's your 100% for paper 2. Many of you, I've seen, you score well in paper 1. You get 70, 75, 80. You get 40, 45 for paper 2. And that brings your whole aggregate to about 56. And that's not where we want to be. If you're getting 75 there or 80 in paper 1, we want you to get your 80% in paper 2 so that we make sure that we maintain your distinction. So without any further ado, let's get started. We're starting here with they tell us, now what do we need to know? Here are your topics. So if you want to write your topics that you need to know for trigonometry, you can take this one down. Let's get up the screen there, the whiteboard. Where are we? Nothing happening there. Let's see what's happening there. Coming up on my screen here. Give me a second. Let's go out of there. Let's go back up there and let's see whether we're ready there. Let's get up our screen. Let's get up our screen. Give me a second. Share screen. Share window. We don't have it there. Give me a second, guys. Give me a second. So let's open that. Let's take that one out. Don't save. Let's open up a new Paint tab. And let's see there. Okay, so let's go back here. We are here. Window there. Share. check. Are we back online here? There we go. I think that's the one. That's the one. That's the one. That's the one. Bismillah. Let's get started. Here we go. Topics. Okay. So what are the topics? The first topic that you need to know in paper 2 under trigonometry. Remember, these are your trig topics, guys. Trig topics. So you need to know, with the aid of a diagram, how to sketch a diagram. The Cartesian plane. How to solve using a diagram. Number 2, trig substitution. I'll explain to you all of this as we go along. Question number 3 is going to be reduction. Question number 4 is always going to be an identity, where you got to prove left-hand side equal to right-hand side. Question number 5, general solution. Question number 6 is non-90-degree triangles. And that's going to be your area rule, your sine rule, and your cos rule. And obviously then your trig functions, and this will give you a total of about 40 to 50 marks. A third of your paper. All right, let's see. This trigonometry here was 29. 29 and 10, 39. 39 and 12, 51 marks. So 51 marks is 50 out of 150. So this year, up till general solution, should give you about 30 marks. That will give you about 30 marks. That will give you about 10 marks, and maybe another 10 marks on your graphs. There we go, grade 11s. That's your breakdown. Make sure you get your full 30 marks here. I'm going to show you how it's done. We're going to start with the diagram first. So we're going to take from 2 past papers. So we all got this down. You know exactly where we're going. We're going to do questions on each of this, and this will take us to our first break. We might even continue after break with a little more trigs, depending on how well we do. So let's go. We are back in, and let's start with the first question from a past paper here, guys. They tell you if, take this one down, if 7 tan theta is equal to 3 and cos theta is less than 0, use a sketch in the correct quadrant to determine the value of, so find the value of sine theta plus cos theta all over 2 sine theta. Here we go. This is your first 6-mark question, your opening question for trigonometry. Right. Now, what method do we use? What method do we use? Right. You use this method here in your mind. Just use scrap. Now, what does scrap mean? S for standard form and SOHCAHTOA. C for draw your Cartesian plane. R for look at your restriction to draw your triangle. A is just for and then P is for Pythag. So just remember scrap. If you can follow these 4 processes, you will get them right all the time. So we scrap it. Let's see how's our onliners doing there. Onliners, how are we doing? Are we good? 96% for math. That's where we're aiming. That's where we're heading. Nope. That's the one. Let's go. Right, so let's follow this process. Standard form. Is this in standard form? So in your answer, the first thing we're going to do, we're going to say tan theta is equal to 3 over 7. That's standard form. You must have a fraction on that side. Yes or no? Standard form. Grade 11s, on-siters, SPs, are we good? Right, that's easy. Divide by 7 on both sides. Now what do we do? SOHCAHTOA. Tan, according to SOHCAHTOA, is opposite over adjacent. So we put a tick there. We're done with SOHCAHTOA. Yes or no? You guys following me? Cartesian plane. Let's draw the Cartesian plane. Restrict. So we're done with Cartesian plane. Let's look at our restriction. Where is tan positive? Tan is positive in quadrant 1 and quadrant 3. Yes or no? But where is cos negative? Less than 0. Between these two quadrants, where is cos negative? Quadrant 3. So wherever I have a double tick, that's where I draw my triangle. And theta is there. There we go. And now we use Pythagoras, so theta tan. Now pay attention here. Here's a catch here. Here's a catch. So I just want to erase this. You all took down scrap. I just want to redraw the triangle on the side here. I want to redraw it here on the side. So we have that, and we have that, and we've got this, and we've got that. Oops. There's your 90 degrees. There's your 90 degrees. That is angle theta. Tan is opposite over adjacent, 3 over 7. Be careful. Can a value below the x-axis be positive? Guys, no, that has got to be negative. And can a value to the left of 0 ever be positive? So both of them are negative, because negative divided by negative will give you a... Be careful to put in your signs. Be careful, don't mess up. If you don't put in a negative, you're in big trouble. You're going to get everything wrong afterwards. Now we use Pythagoras to complete. We want our hypotenuse. So h squared is equal to minus 3 squared plus minus 7 squared. We're using Pythag. So h squared is equal to negative 3 squared is 9. 7 squared is 49. H squared is equal to 49 plus 9, 58. So therefore, h is equal to the square root of 58. You can either say h or you can say r. It's your radius. Square root of 58. And there we go, we're done. Now we complete with the diagram. Make sure you get your diagram correct. Incorrect diagram, everything else is wrong afterwards. Now we find, now only do we go to our, now all we do is we substitute. We use SOHCAHTOA to substitute. So you can start with it, don't wait for me. Find the value of sine theta plus cos theta over 2 sine theta. So substitute from your diagram. Now that you've got your diagram, substitute the values, use your calculator. They say without the use of a calculator, so obviously you want to give your answer in third form. You want to give your answer in third form, no decimals. Onliners, how are we doing? Are you getting this one right? Mahala marks. Yes, Ayatandwa, you are 100% correct. Mahala marks. Okay, so all I'm going to do, I'm erasing the Pythagoras. And let's do the algebra, the substitution. Now comes the algebra part of it. So we have sine theta plus cos theta all over 2 sine theta. Sine theta, we know, is opposite over hypotenuse, minus 3 over root 58 plus cos theta, adjacent over hypotenuse. Soka tawa, adjacent over hypotenuse. All over 2 sine theta minus 3 over root 58. There we go. We substituted. -3, -7 is -10. So they probably want you to show your calculations. So I'm just going to move over to the side. So we have, this is equal to -3 minus 7 is -10 over root 58 divided by, that's over 1, -6 over root 58. Now we tip and times -10 over root 58 times root 58 over -6. Root 58 will cancel. Negative divided by negative is a positive. 2 goes into there 5 times. 2 goes into there 3 times. Your final answer, 5 over 3. And there we go. We just substituted. Let's check our onliners. Did any of you get 5 over 3? Yebo, everybody got 5 over 3. Well done. A round of applause to you. Well done, well done, well done, guys. Well done. There's your first 6 marks in your paper. Ivan Bongani Sibanda, good morning. Good morning, good morning. Welcome. Welcome, precious. Hey, you guys are moving. You guys are machines. Your brains are fresh this morning. Lovely. Lovely. Let's see if we can choose another one from another. Right, here's one more for you. Here's one more like that. So like I said, I'm using from 2 past papers. One more, and we are done with drawing a triangle. We're then going to go into substitution. Right, so here goes. I'm done with this. Take that down. I know many of you have taken this one down already. You can already start with example number 2. Example number 2. If -3 sine beta minus 2 equals 0, and beta is an element of 0 to 270. With the aid of a diagram, find the value of 1 plus tan squared beta without the use of a calculator. It's exactly the same, only different dynamics. Same process, same procedure. Come, guys. Let's see. Let's see you crack this one without me. In your answer. Guys, what method do we use? Scrap. Standard form, Sohcahtoa, Cartesian plane, restriction, and Pythagoras. Then all we do is we use Sohcahtoa to substitute. Boom. That's your answer. Easy peasy, lemon squeezy. Let's get it into standard form. -3 sine beta is equal to 2. So sine beta will equal to 2 over, or -2 over 3, right? Because we're dividing. I hope you all got that. Sine is opposite over hypotenuse. You draw your Cartesian plane. 0 to 270. 1, 2, 3. Remember, where there's a double tick is where we draw our triangle. Where is sine negative in these 3 quadrants? Again, it's in quadrant 3. Because sine is positive here and sine is positive. We need to see where is sine negative. That's beta. Sine is opposite over hypotenuse. And now we just use Pythagoras to solve for x. Be careful. 3 squared is equal to x squared plus -2 squared. 9 is equal to x squared plus 4. X squared is equal to 9 minus 4 is 5. X is equal to plus or minus the square root of 5. It's to the left, so it's minus the square root of 5. Easy. Can you see how quick that's done in under 30 seconds? Now all we have to do, therefore, 1 plus tan squared beta is equal to 1 plus, what is tan beta? Tan, opposite over adjacent, minus 2 over minus root 5 squared. This is equal to 1 plus negative 2 squared is 4 over, so they both negative. Negative divided by negative is positive. Root 5 squared is 5. So 5 over 5 plus 4 over 5, your answer is 9 over 5. And there we go. From 2 past papers, we got full marks. 6 marks and 6 marks. You won't get 2 of these in one paper. You'll only get 1. Onliners, did you all get 9 over 5? Yeah, boy, yes. Always 2. Luandle. These guys are on fire. Ayatanwa, how you got 14 over 5, brah? How you got 14 over 5? 9 over 5. Oh, there's it. Uzair and Hazel again. Hazel got it right. Who the hell is Hazel? Right, let's go to the next one. I'm going back to that past paper, the first pass. Right, we're now going on to trig substitution. Now watch this. You'll get this till grade 12. All these concepts till grade 12. Remember, this is 11 and 12. Right, if sine 32 equals P, find the following in terms of P. Find the following in terms of P. Question number 1, 10 minus 32. Number 2, sine 418. Again, we use scrap here. You use scrap for substitution as well. You use scrap for substitution as well. So let's get it into standard form. Standard form is P over 1. Cartesian plane. Do they give me a restriction? No. So we just draw it in the first quadrant. That's 32 degrees. This is P over 1. So let's just take that out. P over 1. Let's write it nicely there. P over 1. So sine is P over 1. And we're going to use Pythagoras to find x. So 1 squared is equal to x squared plus P squared. We want x. 1 minus P squared is equal to x squared. X is equal to plus or minus the square root of 1 minus P squared. X is equal to, it's on the right hand side, the square root of 1 minus P squared. And there we go, we are done. Yes or no? We completed the diagram. Now we answer the questions. Tan of negative 32. Therefore, tan of negative 32. They're just testing, do you know your negative angles? Tan of a negative angle is minus tan 32. But if it was cos negative 32 is what, guys? Positive. Cos of a negative angle is positive. Tan of a negative angle is negative. Sine of a negative angle is negative. But cos of a negative angle, the negative falls away. So make a note of that. I hope you remember that. Cos of a negative angle is always positive. Now, that's minus. Now, tan 32 is P over, opposite over adjacent, square root of 1 minus P squared. And there we go. We are done. We're done with the first question. Do the second one. We are done with the first one. Let's do the second one. This was just Pythagoras that I did on the side. Number 2, sine 418 is going to equal to sine 360 degrees plus 40 plus 18. Because 40 will take me to 400 plus 18 is 58. Now sine, this will give me sine 360. When we reduce, will remain sine 58. 360 plus is in my first quadrant. Sine is positive, so we leave it as sine 58. Now, if this is 32, that angle is 58, sum of angles of a triangle, because these two add up to 90. So sine 58 is opposite over hypotenuse, the square root of 1 minus p squared over 1, which is equal to the square root of 1 minus p squared. And there we go, we are done. We use the triangle, we use the diagram to substitute the values. Let's look at the other past paper. Let's see which one did they give you there. Yeah. You guys want another practice one to do on your own? 6 marks, right? 2 marks, 2 marks, 2 marks. This one here was just 2 marks and 3 marks. This here was 5 marks in total. Can you see how easy is it? Really, really, really simple, guys. So for those of you who took this one down, you can do the next one. Start with the next one already. If cos 75, take this down, if cos 75 is equal to m, find the following in terms of m. Cos squared 105, sine 15, tan 15. Go for it. 2 marks, 2 marks, 2 marks. You have to draw the triangle. No doubt, no question about it. Drawing the triangle is not optional. It is compulsory. Drawing your triangle is not optional. Drawing your triangle is compulsory. Onliners, you guys are on fire. Yes, Mr. Jabbar, you say so easy. Yes, it is easy. If the whole country finds it easy, everybody will get 100%. Let's go. Mr. Jabbar, sending love all the way from Cape Town. The city of love. I think Cape Town was also recognized as the jazz capital of the world, wasn't it, at one stage? No? Am I imagining? Or I just made it up? Maybe. I just made it up. Ah. Right, so here we go. Let's draw our triangle. No, guys, just watch here. You don't, if no restriction is given, just draw a triangle. You know it's going to be in your first quadrant. It's fine. Just draw a triangle. 75. M over 1, but it's cos, so it's adjacent over hypotenuse. Adjacent over hypotenuse. So that's going to be your y value. So obviously you know that using Pythagoras, 1 squared is equal to m squared plus y squared. One minus m squared. So that's the square root of 1 minus m squared. There we go. Let's answer the questions. Question number 1. Therefore, question number 1. Cos squared 105. What is the relationship between 105 and the angle that they gave you? So this is equal to cos squared 180 minus 75. Be careful here. 180 minus 75 is in your second quadrant. Cos is negative. But anything squared is always positive. So this will just remain cos squared 75. Don't ask me what happened to the negative sign. Negative squared is positive. Many of you in the exams, you go and write minus cos squared 75. You'll get it wrong. They're hoping, it's a trap. They're hoping you make that mistake. 180 minus is in quadrant 2. Yes, we know that cos is negative. But the question says squared. Anything squared is always positive. Now, cos 75 is m. So my answer is m squared. Cos 75 is m. And don't forget the squared. So your final answer in terms of m is m squared. Onliners, did you get the first one right? M squared. Yes. Some people are writing 2m. I hope you are not writing 2m. Oh, is that the answer for question number 2? I don't know. Let's check. The answer to question number 2. Sine 15. Sine 15. What is the relationship between 15 and 75? This is sine 90 minus 75. Now we have to reduce. Sine 90 will change to cos 75. 90 minus is in my first quadrant. Sine is positive. So cos 75, your final answer for question number 2 is just what? M. Because they told us cos 75 is m. Agreed? SPs, are we good? Are we awake? No? Some of you are babala. I won't say who, I'll just look. No, never mind. You slept early last night. Lekker moeg, ne? Yeah. Yes, you could have done that one as well if you didn't reduce it. If you call this angle 15, then sine 15 here would have been m over 1. Perfect, no problem. No problem. Brilliantly identified. I smell distinctions coming up already. Nudge, nudge, wink, wink. The last one, 10, 15. 10, 15 is going to be again, in fact, here, if we use this as our reference angle, 10 would be opposite over adjacent, would be 10, 15 would actually be m over the square root of 1 minus m squared. If we use 15, because then this would have been my opposite, that would have been my hypotenuse, and that would have been my adjacent. Opposite over adjacent would have been m over square root 1 minus m squared. There we go. Fantastic. Fantastic. Onliners. Well done, well done, well done. Did you guys get it right? Did you guys get it right? They just worried about Hazel, brah. Who is Hazel? That's the big question for this weekend. Is Hazel here? Who's Hazel? Hazel, are you a supermodel? The guys are going crazy for you. Hazel, where are you, Hazel? Right, let's go, let's go, let's go, let's go. Right, next question. Okay, reduction, simplify for 7 marks. Let's go. Cos 180, cos of 180 minus x times sine x minus 90 minus 1. Be very careful how you read your question. All over tan squared 540 plus x. Sine 90 plus x. Cos negative x. Oh, I love this problem. It tests all your skills. It tests normal reduction. It tests your anti-clockwise angle. It tests a square angle. It tests an angle greater than 360. It tests your cofunction, and it tests your negative angles. Whether you know all these rules in one question, that's why it is worth 7 marks. Give it a go, guys. If you get this one right, you're a boss. It means you know your work with regard to reduction. It means you know your work with regard to reduction. Fantastic. Let's see. Every part needs to be sorted out. This is like a compound C4 bomb with 5 wires. Make sure you sort out all the wires correctly. One mistake in here. Kaboom. Inna lillahi. Maningal. One mistake. Tell us down. What you say, Khalid? How's our onliners doing? Are they fired up? Yeah, Romana, how are we doing there, Romana? We didn't even see you, Romana. Hello, Romana. We don't even have a camera for you to say, how's it? The camera is not Romana friendly. This is so easy, guys. If you know how to do this, you're actually going to look forward to your exams. Let's do this. Let's do this together. Come. Many of you, your pens are just down. You just enjoying, you eating popcorn and drinking coffee, enjoying the show. You said, I'll sort it out when the time comes. Come on, this is easy. Cos 180. Remember, 180 and 360, the name stays. 90 and 270, the name changes. So cos 180 will remain cos x. 180 minus is in my second quadrant. Cos is negative. Was that difficult? No. Now sine x minus 90. Now what do we do here? Watch here. Watch what we do with that. Where is sine? Sine is in your first quadrant, right? We are moving 90 degrees anti-clockwise. So from there to there. Right. Sine 90 will change to cos x. What is sine in your second quadrant? Positive or negative? Guys, what is sine in your second quadrant? Positive or negative? So we leave it as positive. That's how we do our anti-clockwise angle. I looked for sine from my original, and I moved 90 degrees anti-clockwise. If it was 180, x minus 180, I would have came all the way and stopped here. Then it would have been minus cos x. And if it was 270, it would have came all the way here. And if it was 360, it would have came all the way back. So, just to show you, sine was there, and we moved 90 degrees anti. But because it's 90, we changed it to cos. Sine in my second quadrant is positive. -1. Be careful, BODMAS. Remember, we multiply first. Now, tan 540. We minus, the minute you have an angle greater than 360, you minus 360 from it. So 540 minus 360 is 180. So it's the same as tan 180 plus x. So tan 180 will remain tan squared x. Grade 11s, do I need to check whether it's positive or negative? No. Why not? It's square. Anything squared is always. Are you with me? Girls, you okay? You sure? 100%. Good. Next part. Sine 90. Does the name stay or change? 90 and 270. Does it keep the name or change the name? The vertical line, 90 and 270, changes the name. Just think of it like an electric fence. You get there, you get electrocuted, and you change. Right. 180, 360, horizontal. Think of you as laying down, you chilling, you stay. 180 and 360, name stays. 90 to 70, name changes in reduction. So sine 90, name changes to cos x. 90 plus is in my second quadrant. We don't look at cos, we look at sine. Sine in my second quadrant is what? Positive. Times, I just told you this, cos of a negative angle is what? I can't hear you. Positive. If this was sine negative, you'll take the negative out. If this was tan negative, you'll take the negative out. But it's cos negative. You don't get cos of a negative angle. Why? Because 0 minus is negative, cos in this quadrant is positive. And then 0 plus is your positive angle in your first quadrant, cos. So you never get cos of a negative angle. You can get minus cos of an angle, but you can't get cos of a negative angle. Now all we do is we convert to sine and cos. Remember, the simplest form in trigonometry is to convert everything to sine and cos. That's what we want to do. And algebra, of course. So let's go. Negative cos times cos is what? Cos squared x minus 1 all over tan squared x is sine squared x over cos squared x times cos x is cos squared x over 1. Algebra now. Algebra, and I see an identity there. So cos squared and cos squared will cancel. If I swap this around, I get minus 1. Now there's a bit of a challenge here. Do you think they made a mistake in this paper? Because you're supposed to get, if I took out the negative, then I get cos squared x plus 1. I'm supposed to get 1 minus cos squared x. This can't be. Just give me a second. That was cos. No, but look here. Look here. Sine 90 will change to cos x, right? Ah, wait. Sine is in our second. Ah, there's my mistake. Right? Okay, here we go. Wait, it's fine. Wait. I found my mistake. I found my error here. My error is here. I'll tell you why. Sine x minus 90. Sine is in, all right, so it is going to change to cos x. Sine 90 will change to cos x. Sine is in your second quadrant. Sine lives in which quadrant? Second quadrant. And we're moving 90 degrees anti-clockwise. So I was stupid. I started in the first. I shouldn't have. I should have started in the second because sine lives in your second quadrant. Now we move 90 degrees there. So what is sine in this quadrant? Negative. There's the... I know what you did. You added 360 to it to get... Right, okay. Still becomes negative. I'm just showing you a different way. Right. Let's go. Negative times negative. Right, so now we have cos squared x minus 1 over tan squared x is sine squared x over cos squared x multiplied by cos squared x over 1. That and that will cancel out. I can flip this over. That's minus into 1 minus cos squared x all over sine squared x. Now, what is 1 minus cos squared? Your identity. Come on. 1 minus cos squared is what? Sine squared. So it's minus sine squared x over sine squared x. That and that will cancel out. Don't forget the negative. What's your answer? Minus 1. There we go. There we go. So just to show you again this anti-clockwise angle where you got x minus an angle. We start there. Where does sine live? Second quadrant. We move 90 degrees anti-clockwise. Sine in this quadrant is negative. Sine in the third quadrant is negative. That's why it becomes minus cos x. And sine 90, because we use 90, we change the name to cos. That was the catch. Right. Excellento. Let's see. Our onliners, did you all get it right? Here we go. Here we go. You want another one? Let's give you one more to do on your own. Let's check. Right. So here's one in terms of angles. Reduction in terms of your special angles. Come, guys, concentrate, 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 guys. Onliners are seeing dead people in math. Beautiful. Seeing dead people. Welcome to grade 11. Right, let's do this one. Right, simplify. Sine 120. Tan 300. All over cos negative 60. Tan 225. Go for it. 7 marks. Huh? Let's check. Sir, isn't you change cos squared to 1 minus sine squared, then you cancel the ones out and you get 1. No, I had to, the cos squared to 1 minus, no. Remember, no, I didn't change the cos squared to 1 minus. I swapped it over and took out the negative sign, Zafar. I swapped it over and I took out the negative sign in the previous one. I swapped the 2, pulled out the negative sign. Then the 1 minus cos squared becomes sine squared, but I took out the negative. So it was minus sine squared. Hope that answers your question, Zafar. James by the gate. Right, let's go. Let's go, let's go, let's go. We need to reduce here. So we need to use our quadrants, guys. We need to use our quadrants. So sine 120 is 180 minus 60. Don't use 90 plus 30. If you wanted to, you could. But we want to try and keep the name, not change the name. Times tan 300 is tan what? 360 minus 60. All over. Cos of a negative angle. What happens there? Falls away. So it's just cos 60. Tan 225 is going to be tan 180 plus 45. Did you all get that? Did you all get that step right? Well done. Now let's reduce. Sine 180 will remain sine 60. 180 minus is in my second quadrant. Sine is positive. Tan 360 will remain tan 60. 360 minus is in my fourth quadrant. Tan is negative. Over. Cos 60, I'll leave it as cos 60. Times tan 180 will remain tan 45. 180 plus is in my third quadrant. Tan is positive. Sine 60, root 3 over 2 times negative. Tan 60 is root 3 over 1. All over. Cos 60 is a half. Right? Times tan 45 is 1. Now just use your calculator here. You're going to get a negative answer. So let's go to our as long as we give our answer in third form, we are okay. So let's go. Root 3 over 2 multiplied by square root 3 equals, and let's divide that by a half. Your answer is 3. Don't forget this negative here. Your answer is minus 3. Final answer. Let's check our onliners. Did you all get negative 3, guys? Well done, Tini. Well done, Kamogelo. Well done, Precious. Well done, well done, well done, well done, well done, well done, well done. Absolutely amazing. You guys are sharp now. Now we go on to, when is break? 25 minutes. 25 minutes for break, but we're going to do identities first. After identities, we'll go for break. We'll come back. We'll do general solution. Yes, well done, Benjamin. Well done, Karabo, Ella Renee. Absolutely amazing. You guys are superstars. You guys going to get full marks in your exam. Uthman Sunday, you glad you're here? We glad to have you. You got 0. Hope that won't be your final exam mark, but yeah, inshallah. Let's go. Getting 0 is not a good sign. Right. Now let's look at identities. Right. Now, identities, you can use Ali. You can use Ali. You know Ali? Ever heard of Ali before? No. Step number 1, algebra. AL for algebra. Step number 2, look for your identity. And then left-hand side will equal to right-hand side. So who does identities? Who does identities? Ali does identities. Ali does identities. Do your algebra first, then look for your identity, the left-hand side. And you want to convert everything to sine and cos. Remember, sine and cos is your simplest in trigs. Let's start off with the easy one. Prove. Remember, identities will always say prove, or it will say show that. Prove that sine x plus cos x all squared is equal to 1 plus 2 sine x cos x. Answer. Right, put your pens down. Put your pens down. We start on the complex, moving to the easy. You never start with the easy, moving to complex. It's only common sense. It doesn't take rocket science to figure that out. So we start on the left-hand side. What did I say? What's step number 1? Algebra. So here we go. Sine x plus cos x all squared. In algebra, this would be sine x plus cos x into sine x plus cos x. Yes or no? Is my algebra done? Not yet. I need to remove the brackets. What do? I FOIL it. First, outer, inner, last. So let's go. Sine times sine, sine squared x. Outer plus sine x cos x. My 2 inner plus sine x cos x. My 2 last terms plus cos squared x. I'm just doing it here because I don't have space. Right, algebra done. Here's it, algebra done. What do I look for now? Identity. Isn't sine squared plus cos squared 1? Yes or no? Guys, isn't sine squared plus cos squared 1? And then I got 1 sine x cos x plus another 1 sine x cos x. 1 cell phone plus 1 cell phone is what? 2 cell phones. And there we go. It is equal to your right-hand side. Left-hand side is equal to your right-hand side. Ali does identities. We're going to do more. I'm going to do another 2 or 3 more. This is the basic. This is the ultimate basic. This is level 1. Let's go on to level 2, 3, 4, but we're following the same train of thought. Ali does identities. And obviously, if you see a 10 in it, but first do your algebra first, man. Get rid of your algebra. Brackets, third sign, when you're multiplying into brackets, squares, cubes, all of that. Get rid of all of that. Even fractions, get rid of that. Automatically, once you're done with that, the identity will stare you in the face. Then you substitute your identity, and the left-hand side will equal to right-hand side. So for those of you who are done with this one, just check the next one out. This is level 2. Prove that 1 over 1 plus sine x plus 1 over 1 minus sine x is equal to 2 over cos squared x. Start on the left, do the algebra first. You're adding 2 fractions. Come, take it down. Die mense, hulle is moeg, né? Then I throw you into the deep end. These ones are just for explanation purposes. But they also exam type, eh? Don't think that the ones that I'm giving you for explanation or explaining purposes are not examinable. Of course, they could test you. There's a possibility. But after these 2, I give you 2 from the past papers that I've chosen. Right. Thumbs up. Quite smart. Let's go on the left-hand side. We're adding 2 fractions. Left-hand side. I'm doing the LCD, lowest common denominator. What's your LCD? 1 plus sine x into 1 minus sine x. Yes or no? Algebra. Now, that and that will cancel. You left with 1 minus. 1 minus sine x times 1 is 1 minus sine x. Plus, there's your plus. 1 minus sine x and 1 minus sine x will cancel. You left with 1 plus. 1 plus sine x times 1 is 1 plus sine x. So I'm just doing the LCD. Now we simplify. We're not done with the algebra. Minus sine x plus sine x is 0. Grade 11s. 1 plus 1 is? So clever. All over. We need to get rid of these brackets. 1 plus sine x, 1 minus sine x. A plus b, a minus b. X minus 2, x plus 2. In algebra, what is that? Isn't that the difference of two squares? So, when you're doing difference of two squares, you only need to do the first, the outer and the last. You don't need to do outer and inner. They'll cancel each other out. You can only do, although we are foiling it per se, but we're only doing first and last. Outer and inner from foil will kick each other out. So 1 times 1 is 1. Positive times negative is negative. Sine times sine is sine squared. Is the algebra done? Yes. Now I'm done with the algebra. Is the identity staring you in the face? I can't hear you. Is the identity staring you in the face? What is 1 minus sine squared? And isn't that your 1 minus sine squared? There's your identity. Ali. There's your identity. 1 minus sine squared is what? Bada bing, bada boom. Game over. Time to fight. Time to fight. Yo, the next one looks rough. I haven't done the next one before, and I haven't seen the next one before. Right. Round 2. Fight. Let's go. Let's see if you guys are going to KO this though. Come, my friends. Come, my friends. Let's go. Prove. For 5 marks. Cos squared x minus cos x minus sine squared x all over 2 sine x cos x plus sine x. Oh my Lord. 1 over 10x. Sure. Minus 1 over sine x. They are trying to destroy us. They are trying to take away our happiness. In this case, both sides are not simplified. Because you got a 10, you got a fraction, you got to do algebra. I'm thinking, I don't know. Like I said, I don't have a memo here, but I'm just saying. I'm thinking. Left-hand side is complex, right-hand side is complex. Something tells me both sides need to be adjusted. We need to do algebra. We need to work on algebra on both sides, bring it in terms of sine and cos. Right at the bottom, left-hand side must equal to right-hand side. Let's go. Let's try. Come, Bismillah. Answer. Let's go. Left-hand side. Let's go left-hand side. My denominator, I've already picked up something. My denominator, I got 2 terms. What's common in the 2 terms? Sin x. What am I left with? 2 cos x plus 1. I see something. I smell the answer coming up. This already gave me an indication that I must have factors on the top so that that and that must cancel out. The only way to make the numerator a quadratic equation, watch here. To make this a quadratic, watch here. I got cos squared, I got cos. My problem is the sine squared. So watch what I do. Put your pens down. I need to make this a quadratic equation. So I'm now going to say cos squared x minus cos x minus, there's my identity. Because there's no more algebra. That's the only algebra I had. So now identity, sine squared is 1 minus cos squared. I hope I'm right. Don't write. Don't take it down. I might be wrong. I'm doing it with you as if I'm writing this exam with you. I got no memo. Let's go. Cos squared x minus cos x minus 1 plus cos squared x. Something's happening here. Something's happening here. Over sine x into 2 cos x plus 1. Now I know one of my factors on the top has got to be 2 cos x plus 1 because that and this must cancel. So I know where I'm going with it. Cos squared x plus another cos squared x is 2 cos squared x minus cos x minus 1 all over sine x into 2 cos x plus 1. What did I say? That's a perfect trinomial. Perfect trinomial. I'm going to factorize it. And I know that one of my factors on the top must be one of my factors at the bottom. 2 cos x plus 1. So I'm going to put in 2 cos x plus 1. Now 2 cos x times what will give me cos squared? Cos x. Yes or no? And then plus 1 times what will give me a minus 1? Minus 1. Now let's check it out. Let's just do a check. 2 cos times cos will give me 2 cos squared. My two outer terms, minus 2 cos x plus 1 cos x will give me my minus 1 cos x in the middle. And that will give me first, outer, inner, last. I don't think I'm right. I know I'm right. That and that will cancel out. I'm left with cos x minus 1 over sine x. And that's as simple as I can get my left-hand side. In terms of sine and cos, okay, take this down. I know we're right. I know we are right because we now need to have fun on the right-hand side. And that right-hand side is also going to give us a cos x minus 1 over sine x. Guaranteed. It has to. Nice question. Right, you've taken this one down. This is the left-hand side. So what did I do here? I took the sine squared. I converted it to 1 minus cos squared. All I did was I removed the brackets. Then I collected the like terms. And then it ended up as a quadratic equation. And that quadratic equation I factorized. And then I got it in its simplest form. Right, now let's do the right-hand side. Are you done? Have you taken the left-hand side down already? How many of you are still writing? I'll give you a couple of seconds. Learn this one. Learn this one. I'll even tell you which paper this one came out from. Eastern Cape, November 2022. Look for highest common factor. When you see complex stuff, look for HCF, look for quadratic equations, look for factorizing and cancelling. Algebra. Remember, what is algebra? Products, factorization, brackets, surd signs. That's algebra. Fractions, LCD. When you're adding or subtracting, LCD. When you're dividing, tip and times. Algebra. Now let's do the right-hand side. Can I erase here, guys? Can I erase the first step? Because I need space. Okay, I'm erasing right until there. Okay, let's go. Now let's look at right-hand side. Come on. Right-hand side. 1 over 10x is 1 over sine x over cos x. Minus 1 over sine x. Now this times cos over sine times cos. So 1 divided by sine over cos is cos x over sine x. Minus 1 over sine x. Now we do algebra LCD sine x. And what am I left? They're both over the same denominator. So I'm left with cos x minus 1. And isn't it cos x minus 1? Therefore, left-hand side is equal to right-hand side. In its simplest form, in sine and cos, the two sides will always be equal. Right. Take this down. We are going into break. Hope you guys enjoyed the first session. I know you're all hungry. Sunday morning doing math. Onliners. Let's go into break. Break is now, guys. Why are they saying YouTube is a bit delayed? Are we getting a bit of a lag? Okay, guys. We are going into break. We go into break now. Enjoy your break. I see you back at 11 o'clock. 30 minutes. 11 o'clock is break.
If you're joining us now, it is still the Awqaf SA Grade 11 Pure Maths workshop, which is hosted here at South Peninsula High School in Plumstead, Cape Town. I believe now I'm joined by Romana. Romana will be talking to us about the competition. But just before we do so, Assalamu alaikum, Romana. Can you hear me?
Walaikum assalam. How are you?
Romana, assalamu alaikum.
Walaikum assalam. How are you?
Alhamdulillah. How are you doing?
Alhamdulillah, I can't complain. How has the maths workshop been so far?
Romana, I believe our link up is very, very bad at the moment. But if you can hear me, just simply let us know. Just tell us about the Awqaf SA workshop that will be taking place in January. I believe a lot of people are interested when it comes to that competition. Tell us.
So basically, Awqaf runs these maths workshops throughout the year to help our learners improve their maths marks. And we ask our learners to submit their mid-year and end-of-year reports through our online portal. And from there, we select 4 winners. There's a prize for first, second, third place, and most improved. Um, we go through the all the submissions that we get. So basically, all your results, we go through that and we see who's benefited the most from these workshops. And let's say someone only found out about the program in July, and we that someone can is now can potentially they found out about the program in July. They can get the most um, and their marks have improved the most from July to mid-year. For example, they got like 90%. They can get the most improved learner award, and these all of these prizes are cash prizes. So make sure to attend the workshops and submit your result online.
Now, Romana, we've got a bit of a network problem here. I believe you are done talking, but I'm still listening to you this side. Now, if someone wants to enter these competitions, what can they simply do? What is the criteria, as far as joining these competitions is concerned?
So all they have to do is register um, for these workshops, and part of the registration process is submitting their um, maths marks. And from there, Awqaf will look at their maths marks and we assess all
Yeah,
the
in 4
maths
minutes.
marks that we get. And based on the maths marks that we get, we decide.
Thank you very much, Romana. I think we'll link up with you at 1 o'clock again, just to give us that information, noting that we had the problem of the slow network, the signal, the weak signal that was kind of deterring us from giving that full information out. But I believe that at 1 o'clock, you will be back with us to give us that more information. For now, Romana, thank you very much. Uh, we now wait for Mr. Coulter. And for those of you who are perhaps joining us, it is the Awqaf SA grade 11 maths paper 2 here at South Peninsula High School in Plumstead, Cape Town. To make sure that you tell those who don't know to join us, or even if you kind of miss these sessions, then you can go to awqafsa.org. That's where you will get the information about these workshops. To make sure that next week you join us, as we'll be doing grade 10 pure maths workshop at Al Azhar. Do make sure that you are with us, and try by all means to ensure that you enter that competition as it is flighted on the screen. For me now, it is thank you very much. Up until we meet again at 1 o'clock.
Okay. Welcome back, everybody. Hope you guys enjoyed your first break. Onliners, are you back? Everybody back in? Tato, are you in? Sandika, are you in? Maloko, are you in? Lelona, are you in? Sabelo and all the SP learners, welcome back. Hope you enjoyed your breakfast break. We are back in. Do you want to get us up our whiteboard? Welcome, onliners. Hit us up. Talk to us. Tell us how you're doing. And tell me, are you guys ready for round two? Round two fight. Here we go. Oh, it's your birthday as well, Inati. Happy birthday. Happy birthday. Let's all say happy birthday, Inati. Happy birthday. Ah, Uthman, you missed me already. 30 minutes of break and you missed us already. Kailan Naidu, you're learning so much. MashaAllah. Kamogelo says you are back. Now look at this. This is a higher order question. When is break? Your next lunch is at 12:30. We are back. This is a higher order question, guys. Take this one down. Higher order. Beautiful question. These are not your usual questions. These are unusual questions where you've got to apply your mind. Now, it's a 6-mark question. It's the last question of trigonometry, which they hope you won't get 100% for trigs out of, sure, it was 41 marks. They're hoping that you'll get at least only 35. They're hoping that you get the last one wrong. So don't panic if you see a question like this. Tell yourself, this is my challenge question. Generally, leave your challenge questions for last. Because they could take up a lot of your time if you don't know how to do it. So if P is equal to tan A plus sine A and Q, so read the question carefully. P is equal to that and Q is equal to that. So, prove that. Prove that PQ. Prove. They're not saying. So prove that PQ is equal to that times that. Now logically, what would you do? Right. You need to prove that P times Q is equal to that. So in our answer, we're going to start off with PQ. And what is PQ equal to? What is P? P is tan A plus sine A. And what is Q? Tan A minus sine A. Yes or no, guys? I'm going to put a tick and stop. Do you all understand what I did there? Put your pens down. Don't write while I'm writing. You won't understand. You're going to get lost. You're going to lose me along the way. Can you see what I've done? I've started with PQ. There we go. Is equal to, forget about the right-hand side. I'm doing PQ from the original. So PQ here is tan A plus sine A. Q is tan A minus sine A. We're still using, because they're saying proof, we're still using Ali. Who does identities? Right, so this is the algebra. In algebra, what would I do now? In algebra. Remove the brackets, am I right? Difference of two squares. My first two, my last two. I'm talking algebra. AL for algebra. So that would give me tan squared A minus sine times sine is what? Sine squared A. Now I get tan squared A minus sine squared A. They want me to say tan squared A times sine squared A. Okay. So then let's convert tan squared A. What is tan squared A? Sine squared A over cos squared A minus sine squared A over 1. I'm just going to move over here to the side. We're still doing algebra. Common denominator here is what? Cos squared A. So cos squared A into cos squared A once. 1 times sine squared A is sine squared A minus 1 into cos squared times sine squared is sine squared A cos squared A. We're still busy with algebra here. What's my highest common factor here? Sine squared A. What am I left with? 1 minus cos squared A over cos squared A. Now, can I convert this to what they want me to find? There's a sine squared over cos squared. Okay, I'm just going to move over here because of space. So I'm left with sine squared A into, what is 1 minus cos squared A? Sine squared A over cos squared A. Can I make this look like that? Yes, I can. Watch here. Sine squared A over cos squared A is what? And what am I left with? Times what? And here comes my final answer, which is equal to sine squared over cos squared. Tan squared A times sine squared A, which is equal to my right-hand side. So I could have said left-hand side there, PQ, that was left-hand side, is now equal to my right-hand side. And there we go, we're done. I took PQ, I removed the brackets, I broke it down, I moved over here, I found the LCD, and then all I did here was my identity. So algebra, identity, I split it up. It looks like my right-hand side. Now you can take it down. It looks difficult, but it's not. It's all within the framework. It's all within the knowledge that you already have. Onliners, you got it? Onliners, do you have it? It's a solid question. It's a higher order question. And now we're going to do some general solution. Don't overthink your work, guys. Don't overthink your work. If you know your algebra, you can apply, you will get it right. For those of you who have taken it down, you can already start with the next one. I'm not going to erase everything. I know some of you are still writing. Give me the general solution. Six sine squared theta plus cos squared theta is equal to 4 for 7 marks. Now, whenever you see a square, you always want to make it a quadratic equation. And you want to get 2 general solutions. What do we do here? Those of you who have, you can start with this one already. I'm just checking something here. Shift cause. Okay, let's go. Let's go. Let's go with the general solution. Onliners, are you done with the general solution? We want to make it a quadratic equation. So what we want to do here, guys, what we want to do is we want to convert all this into, you can do it in terms of sine or you can do it in terms of cos. Let's do it in terms of cos if you want. Let's do it in terms of cos. Or we can do it in terms of sine. It's entirely up to you. So I'm going to say 6 into sine squared is 1 minus cos squared plus cos squared theta is equal to minus 4. Minus 4 is equal to 0. I'm going to put a tick here. Don't write. Do you all understand what I did there? The sine squared, I converted it to 1 minus cos squared. Agreed? Or you could have converted the cos squared into 1 minus sine squared. It's entirely up to you. Now let's remove the brackets. Why am I doing this? Grade 11s, why am I doing this? What do I want to create? What do I want to create? A quadratic equation. So let's do it together. 6 times 1 is 6 minus 6 cos squared theta plus cos squared theta minus 4 equals to 0. So we're going to get minus 6 cos squared theta plus cos squared theta. 6 minus 4 is 2 equal to 0. Let's divide by negative. 6 cos squared theta minus cos squared theta minus 2 is equal to 0. Factors of 6, factors of 2, that when cross multiplied will give me a minus 1. 3, 2, 1, 2. 6 and 2 will give me a 4. That won't work. That won't work. So let's make it instead of, let's make it 2 and 1. That will work. 3 times 1 is 3. 2 times 2 is 4. I need to get minus 1. Minus plus. Positive times negative gives me a negative. My last sign is a negative. First bracket, second bracket. 3, 2, 2, 1. Let's go. So we go there. We do that. We factorize it equal to 0. 3, 2, 2, 1. To get cos squared, I'm going to put cos theta. Cos theta. 2 times 2 is 4. I need minus 4. I put a minus. 1 times 3 is 3. I need plus 3. I put a plus. Please make sure you put your signs in the right brackets. Now what do we have? We got 3 cos theta minus 2 equals 0. Or we got 2 cos theta plus 1 equals 0. Yeah. Oh, this is supposed to be cos. Whoa, 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 whoa. You are right. Minus 6 plus 1 is minus 5. Let me just double check. I took the question down correctly or incorrectly. Give me a second. Ah, it's 6 sine squared theta plus cos theta, guys. It's fine. It's fine. It's fine. It's fine. Take that out. That's why it's quadratic. Okay, there we go. We're back there. Take that out. Take that out from the question. I put in a cos squared incorrectly there. Sorry about that. There we go. So that's your question. So obviously you couldn't change the cos. You had to change the sine into 1 minus cos squared in order for you to make it a quadratic equation. Thanks for that. I took down the question wrong. So now we have 3 cos theta is equal to 2. Cos theta is equal to 2 over 3. Or 2 cos theta is equal to minus 1. Cos theta is equal to minus a half. Right? That's minus a half. Now we got 2 general solutions. We've got 1, 2 general solutions. Let's give our 2 answers for this. Just going to move over to the side here because of space. Right. So what do we have here, guys? We got cos theta is equal to 2 over 3. So theta is equal to, because we're looking for an angle, we've got to use a shift key. Shift cos 2 over 3. I get 48,2. 18. 48,2 plus k times 360, where k is an element of integers. You can just put plus minus in front of it. For cos, you can just put plus minus in front of it. Or cos theta is equal to minus a half. So theta is equal to shift cos a half. Shift cos negative 0,5. I get plus minus 120 degrees plus k times 360, where k is an element of integers. And there we go. There are your 2. That's why you get 7 marks for it. You want to bring it into a quadratic, factorize it, and give 2 general solutions. Onliners, we okay? There we go. Well done, Siabonga. Right, there we go. Fantastic, Siabonga. Well done, well done, well done. Let's see from another past paper. Let's look at another general solution. Right, for those of you who have taken this one down, you can start with the next one already. I'll give everybody else some time to take this one down. Those of you who are sharp, those of you who are fast and have taken this one down, you can start with the next one. Sine 5 theta is equal to cos theta minus 40. For 6 marks, give me the general solution. Give the general solution. It's a different style. This one, you don't bring it into a quadratic. The previous one, because you had square, you had to bring it into quadratic. This one, you don't bring it into quadratic at all. It's done totally different. I hope you guys have practiced on this before, or have done this in school, or have worked with it with your teachers or tutors. But if you haven't, it's fine. Here's it now. Learn it now. It's worth 6 marks. Let's see, what do we do? Watch here. You leave it as sine 5 theta. You change the cos to sine. Don't change the sine to cos. Change the cos to sine. So this is sine 90 minus theta minus 40. I'm going to put a tick there. Put your pens down. Do you all understand why I did that? Do you understand how I got it from there to there? Remember, sine 90 will change to cos. Yes or no? Now, why did I convert them both to sine? Watch here. Don't write. Why did I convert them both? So you convert the sine to the cos to sine. Let's write it here on the side. Let's write it here on the side. Convert the cos to sine. That's what I did. Right. Now the fun starts. Now it's easy. Watch here. Here's our general solution coming up. The sine and the sine will cancel. The minute you cancel, you know you got two solutions for sine. 0 plus or 180 minus. Yes or no? Remember, sine got how many solutions? 2. Quadrant 1 and quadrant 2. Quadrant 1 and quadrant 2. Yes or no? SP learners, are you following? Right. Now what am I left with? 5 theta is equal to, we don't need to say 0 plus. 0 plus will still leave it. So you just say 90 minus theta minus 40 plus k times 360 or 360k, where k is an element of integers, or quadrant 2, 5 theta is equal to 180 minus, now brackets, 90 minus theta minus 40 plus k times 360, where k is an element of integers. I'm giving you a template on how to answer this questions. It's the first time I'm doing this, but I did other ones similar to this. All I'm doing is I'm copying the template in my head and putting it here. So write it down. Take this down. Now we solve for theta. So take this down so far. We haven't yet solved for theta. Take it down. Convert the cos to sine. Cancel the two signs. Then do 0 plus 180 minus. Now give your two general solutions. Onliners, are you understanding? Are you following? Take this template down and learn it. Take this. This is so important. This is so important. So somebody says they don't follow. Probably they weren't paying attention. I'm going to do it again. You better be listening now. Let's do it again. Last time. Who's that? Ali Gati. Yes, I'm going to go through it one more time. I'm going to go through it one more time. You better pay attention. This is the last time I'm going through it. Here goes. Sine 5 theta is equal to sine 90 minus theta minus 40 degrees. I'm going to put a tick there. Let's see our onliners. Onliners, do you understand what I did there? Give me a yes if you've understood what I did there. I'll wait. Ali Gati, are you paying attention? The guys who are saying you're not understanding, do you understand what I did there? Right. Good. Next step. Ye verstaan. Right. Sine and sine cancels out. But now you can't just put one answer. You need to give two solutions. You need to give solution number 1 and you need to give solution number 2. Solution number 1 is 0 degrees plus for sine. Solution number 2 is 180 minus. So solution number 1 is 5 theta, there we go, is equal to 90 minus theta minus 40 plus k times 360, where k is an element of integers. Solution number 2 is 5 theta is equal to 180 minus this whole thing, 90 minus theta minus 40 plus k times 360, where k is an element of integers. Let's go back to our onliners. First Angela, no. Do you guys understand now? So far, I am not yet done. We need to solve for theta now. Jy verstaan? Baie goed. Right, let's go. 5 theta is equal to 90 minus theta plus 40. I'm removing the brackets. Plus k times 360. So 5 theta is equal to 90 plus 40 is 130. And 5 theta plus theta is 6 theta. Right? 90 plus 40 is 130. Minus theta will go on the other side as plus theta. So 6 theta is 130 plus k times 360, where k is an element of integers. So theta is equal to 130 divided by 6. 130 divided by 6. 21,67. 21,67 plus k times 360 divided by 6 is 60 degrees, where k is an element of integers. That's your first solution. That is your first answer. Now we have to do the second solution. 5 theta is equal to 180 minus into brackets 90 minus theta plus 40 plus k times 360, 5 theta, 180 minus 90 plus 40 is 130 minus theta plus k times 360, 5 theta is equal to 180 minus 130 plus theta plus k times 360, 5 theta minus theta, 4 theta is equal to 180 minus 130 is 150 plus k times 360. So theta is equal to 150 divided by 4, 37.5 plus k times 360 divided by 4, 90, where k is an element of integers. And there's your two solutions. You answer it in exactly, yeah? It's 50. It's 50. Last. Is 50. 50 divided by 4. Danko. 12,5. There we go. But that's the pattern. Learn this. Absolutely important for grade 11 and 12. It's a pattern. It's a template. You guys want to try one more like this? Do you guys want to try one more like this? Right. Sir, do you do it? What, sir? Do it when you change to cos. No, don't change to cos, Sandika. Don't change to cos. Stick to sine. Stick to sine. Let's do one more. Exactly like this. I'm just changing the values. I can ask you to find the 2 points of intersection where the graph cos 2x is equal to sine x minus 30. So say this was graph F and this was graph G. Find the points of intersection algebraically without sketching the graph. So you're going to have to do this. Or give the general solution. Give the general solution. Let's see you guys do it. Come on, do it. Here's the template. Copy and paste the template. Okay, let's see. You should be done by now. It's so easy. You should be done by now. What did I say? Do we change sine to cos or cos to sine? Cos to sine. So this is going to be sine 90 minus 2x is equal to sine x minus 30. Did you all do that? Yes or no? Good. Now what did you do? You cancel the two signs, right? Now we have to give two solutions. So 90 minus 2x, there we go, is equal to x minus 30 plus k times 360, where k is an element of integers. Or solution number 2, 90 minus 2x is equal to 180 minus x minus 30 plus k times 360. And there we go, your problem is solved. Now you just need to solve for x. Was that difficult? No, not at all. So what do we have? Minus 2x minus x minus 3x is equal to minus 30 minus 90. It's minus 120 plus k times 360, where k is an element of integers. So x is equal to 120 divided by 3. 40 degrees plus k times 360 divided by 3, 120, where k is an element of integers. That's your first solution. You'll get 3 marks for that, and now you'll get another 4 marks for that, or 3 marks. 2 solutions. So you'll get 3 marks there, and another 3 marks for second solution. So 90 minus 2x is equal to 180 minus x plus 30 plus k times 360. So minus 2x plus x minus x, 180 plus 30 is 210 minus 90. 120 plus k times 360, where k is an element of integers. So x will equal to divide by negative minus 120 minus k times 360, where k is an element of integers. Boom, 6 marks. Got it right? Yay! Finally! Finally! You have to practice on all these different scenarios. You're not only going to get a quadratic. You might get a quadratic. You might get one like this. What do? Don't only study one. Learn everything. Onliners, did you get it? How did you get 100? So last time I got 5%. Now I'll be getting 100. Okay. 95% improvement, inshallah. Well done, Mashaba. Well done, Mashaba. Brain fried. You have to. Tatum, I can't go slower than this. I've done the same problem 3 times, dude. Come on. All we're doing here, we're solving for x. All we're doing, we are solving for x. This is the algebra part. That's the algebra part. Okay. Right, that brings us to the end of the normal trigonometry. Let's do trigs on different planes. Right, now we're going to do what we call 2D or 3D trigs. Now, very easy. This topic is very easy. You can score full marks in this as well. So, take this diagram down. Take this diagram down. Let's start with this. Let's start with that. That's 90, that's not 90. Right. That is parallel to that. That is angle theta, the angle of depression. This is P, Q, R, S. That's alpha, that's beta, that's X. That's H. Okay. Let's go. Question number 1. Question number 1. Find QR in terms of X, alpha, beta. Question number 2. Show that h, the height, is equal to x sine beta over sine alpha tan theta. 3 marks, 4 marks, total marks 7. Very easy. Very, 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 very easy. Let's answer question number 1. Now you all know for a right angle triangle, we use SOHCAHTOA. For a non-90 degree triangle, we use the sine rule or the cos rule. Yes or no? One triangle will be 90 degrees, one triangle will be non-90. They want QR. They want that side. They want it in terms of x. So let's call this triangle 1, triangle 2. So find QR in terms of x, alpha, beta. X, alpha, beta is all in triangle 2. So we go in triangle 2. I'm going to be using the sine rule. So I'm going to say QR over sine beta, a side over sine of its opposite angle. QR over sine beta is equal to x over sine alpha. So I want QR on its own. I want QR on its own. So times sine beta times sine beta. Sine beta will be gone. QR is equal to x sine beta over sine alpha. There we go. There's your first 3 marks. X sine beta over sine alpha. So we've answered the first question. Onliners, are you following? So you got Kiniselo just said sine beta over sine alpha. No, it's x sine beta over sine alpha. Because you had to use the x, the, what do you call this? The sine rule. Ooh, your calculator said undefined. You weren't supposed to use a calculator, dude. X sine beta over sine alpha. There we go. We're now going to answer the next question, question number 2. Show that H is in which triangle, guys? Triangle 1 or triangle 2? Triangle 1. And I got to use SOHCAHTOA. So I got to use H and QR. Now pay attention. If that is angle theta, these two lines are parallel, then that is angle theta there. Alternate angles. Angle Q is equal to angle theta, alternate angles. Now I need H and QR, opposite and adjacent. So opposite over adjacent is what? Sine, cos, or tan? SP learners? Opposite over adjacent. Opposite over adjacent is what? Sine, cos, or tan? So we say tan theta is equal to opposite H over adjacent QR. But I want H on its own. What's the opposite of division? So I times this side by QR. What I do on the right, I do on the... So what am I left with? H is equal to QR tan theta. But what is QR? Is QR called QR? No. Here's your answer coming up. H is equal to, instead of QR, what we just found, x sine beta over sine alpha tan theta. Done. 3 marks, 3 marks, 6 marks. 3 and 4, 7. Easy. Now let's do one from a past paper. Now that you understand, for a 90-degree triangle, you use SOHCAHTOA. For a non-90-degree triangle, you use the sine rule or the cos rule. Unless they spoke about the word area in it, then you'll find the area. Okay? What, guys, if I had to ask you, find the area of triangle QRS in terms of sine beta, or using angle beta as your reference angle. Actually, not angle beta, angle R. Using angle R as your reference angle, Find the area. Come, I just want to ask you, I want you to just apply your mind a little. Right, so I'm going to erase this. I just want to show you, so let's say find the area of triangle, what was it, PQ, ne? QRS, triangle QRS with angle R as your reference angle, using angle R as your reference angle. It's not difficult. I swear it's not difficult because everything's already given here. I'll show you how it's done. It's so easy, guys. It is so easy. We know what your standard area rule is, right? What is angle R known as? Angle R is 180 minus alpha plus beta. Sum of angles of a triangle. Yes or no? Yes or no? In this triangle here, what is this angle known as? Angle R. Angle R is known as 180 minus alpha plus beta. Sum of angles of a triangle. But, all right, so let's go. Area is equal to half of a side times another side times sine of the included angle. Right, so let's go. Area is equal to half. Now, which two sides am I going to use? I'm going to use that side, and I'm going to use that side because that's the included angle. Are you guys all with me? So which two sides am I going to use? I'm using that side and that side. So half of x times QR. QR, what did we find QR to be? The one side, what's the other side? Isn't it x sine, what was it? It was x sine beta over sine alpha times sine of the included angle is 180 minus alpha plus beta. Are you all following? It's simple. I'm just substituting. Half of a side times another side times sine of the included angle. That's your area. They're asking you for area. What are they asking you for? And that's the area of a non-90-degree triangle. Now let's see, can we simplify this? So area will equal to 1 over 2. X times x would be x squared. Then you're left with sine beta over sine alpha. We reduce this. Sine 180 will remain sine alpha plus beta. Sine alpha plus beta. 180 minus is in my second quadrant. Sine in my second quadrant is positive. So your final answer is here. So you got x squared sine beta sine alpha plus beta all over 2 times sine theta is 2 sine theta. And there we go. That's your area in terms of those alphabets. Now when they give you the values of the alphabets, all you have to do is substitute it in here. Bada bing, bada boom. You then got the area of that triangle. Oh God. Looks like somebody didn't do the area rule in school. Area of a triangle is half of a side times a side times sine of the included angle. I hope you guys were taught this at school. Were you taught this? Yes. I'm just substituting half of a side times another side times sine of the included angle. If I gave you, I could give you anything. Just to show you something here. So if you didn't understand this one, relax. Don't get a hernia. Right, let's look at this triangle. Okay, I tell you that this is X. I tell you that this is B. I tell you that this is angle theta. Right. Give me the area of this triangle ABC. Find the area. Find the area. So if you didn't understand the last one, pay attention to this one and then compare the two. It will make sense. Find the area of triangle ABC in terms of X, theta, and beta. Come on, this is easy. This here is like 10 seconds. This is 10 seconds. Those of you who didn't understand the last one, you will understand this one. If you didn't understand the last one, get this one right, you'll understand the last one. Then we're going to do one heavy one. We're going to end up this one from a past paper. Then we're done. Then we're done with this. Then I think we can move into Euclidean if you want to. We can already start going into Euclidean. How's your guys' trig graphs? Trig graphs is easy. You guys want to do 1 or 2 trig graphs? Don't understand trig graphs. Sine, cos, and tan. Show of hands. How many of you want to do trig graphs here? Be honest. How many of you want to do trig graphs? I'll do it. I got no problem doing it. Okay, so then we'll do trig graphs. Patrina, love you, sir. Love you too. Tatum, does anybody have panado? Yo, brah. Panardo. Panardo. Right, so this is very easy, guys. This is very, very easy. Let's go back here. So area is equal to half of a side times another side. That's your answer. Half of X times B times sine of angle theta. Finish. So if you want to simplify this, this is all over 1. So this would be XB or BX sine theta over 2 times 1 is 2. And that is the formula for the area of that shape. You have to use the included angle between the two sides, adjacent sides. You can't use that angle, you can't use that angle. You have to use the angle between the two sides. It's sine of the included angle between the two given sides for area. Sine of the included angle between the two given sides. Are we all okay? You ready for the last one? Are you ready for the last one? Here we go. Okay, let's go. I haven't done this one before, neither have I seen it before, but let's go for it. So we got that. We got that. So clearly that is a 90-degree triangle. So I know already in my mind I'm going to be using SOHCAHTOA here. Then they give you something like this. And they give you something like that. And that's non-90 on the ground. So there I'm going to be using sine rule or cos rule. Can you see how you identify which rule you're going to be using? Grade 11s, are you following? It's not difficult. I drew a 90-degree triangle, so I know Sohcahtoa. I drew a non-90-degree triangle, so I know the only rule I can use is sine or cos. Then we got another line coming from here, right across here, that is also non-90. So you got a triangle there on the top, you got a triangle on the side, and they're telling you that this here is also 90. Okay, so let's identify our shapes. Not difficult at all. This is P, that's X, that's R, that's angle theta. This is 120 degrees. This is also X. This is S. This is Q. So triangle PQR is 90. Triangle PQS is 90. Triangle RSQ is non-90. And triangle RPS is also non-90. So I got two non-90 and two 90. Okay. Question number 1. Love you too, Lena. Lana. Determine QR in terms of theta and x. Find theta in terms of theta and x. Come, go for that. Do that one. Come, we do it step by step. Do the first one. Patrina. Love you too. Love you all. Crack math. Love it. I tell you people, in all the workshops, best workshop you've ever been to, mashallah. The reason why I'm doing what I'm doing for the rest of my life is because I promise you, and many of you won't believe it, I failed grade 11 math. I had below 20% in grade 11. I knew nothing in grade 11. Grade 12. Grade 12. June exam, grade 12. I had below 30% in mathematics. June, grade 12. Prelim and finals, grade 12. Believe it or not, I'm telling you, I swear on my dead parents. Allah give them Jannah. I promise you, I got 100% at the end of grade 12. I finished a 3-hour paper in 1.5 hours. I did the same paper twice. From failing in June to 100 at the end of the year. And wallahi, guys, you can do it. You can do it. You got a 1-year head start from me. And the way I taught myself, the way I was shown, and the way I worked, but I'm not going to lie, blood, sweat, and tears in grade 12. But the way I understood it is the way I'm hoping to get it across to you. Hoping that you're getting to enjoy it, finally seeing it, and applying your mind. That's all it takes. And that's when I promise myself I'll be doing this till the day I die. Ameen. Let's go. I promise you. Inshallah, I'll do this till the day I die. I made a promise. I said, if I could do it, the rest of the country, everybody can do it. I saw nothing. I promise you, at the end of grade 11, beginning of grade 12, when I used to look at the teacher right on the board, I swear it looked Chinese. No, don't say same. No, you're making me scared. I saw Chinese. I knew nothing. But finally, when I understood the first concept, that algebra is my key. If I master my algebra, I'll master everything. Then I realized, okay, I need to master the formula for each subject, for each topic, use the right formula, substitute, using my algebra and making sure my algebra is on point. That's how I got 100%. I promise you, you all can do it. Every single one of you here. There's hope for everyone. You are 1 year more advanced than me. You got time. But work. I'm not going to lie. That June, after I got 22% in June. No, yeah, I got about 22, 23 in June. Before June, I was below 20%. June exam, I got about 22, 23%. I looked at it and I said, my God, even the dom cops in my class are passing maths and I'm failing. There's no way I'm failing math. No way I'm failing math. And I took that holidays, at June holidays, and I worked from 8 in the morning to 10 at night, every single day with somebody showing me how it's done. Right. Then I mastered it. I said, all right, after I do a topic, let me do. I worked until I was blue in the face. When it came to the paper, just looked at the paper and said, right, everything looks familiar. Let's go. 3-hour paper, 1.5 hours. Same paper, twice. Get there. Something to work towards. For me, it was just for my own. I just wanted to say, I could do it. So every single one of you here, online and on-site, every single one of you have got the potential to do it. Just consider it. It's up to you. The decision is yours. You decide whether you're going to pass or fail. If you've told yourself already, I'm seeing Chinese, I'll never pass, nothing makes sense, well, then you'll get Chinese marks. Anyway, let's go. Find theta in terms, find QR, man. Find QR in terms of, find QR in terms of theta and x. So where's QR, guys? Where's QR? So highlight QR. Let's highlight QR. In terms, they only want theta and x. Theta and x. There's x, there's theta. That means, which triangle am I looking at? PQR, isn't it? Common sense. So we say in triangle PQR, we want this side, and we got that, and we want that. So SOHCAHTOA. So let's use SOHCAHTOA. That's opposite and that's adjacent. Opposite and adjacent is what? Tan. So tan theta is equal to x over QR. What do they want? QR on its own. So algebra now. We use the right formula. Now comes the algebra. So I want QR. What do I want? So flip this side, flip that side. So what am I left with? QR over x is equal to 1 over tan theta. So QR on its own times x, QR is equal to x over tan theta. There we go. X over tan theta. Finish. Done. You got your first 3 marks. The minute you get it in pencil, write it on that line because you're going to be using it in the next question. Now, the next question is the heavy one for 5 marks. So let's see. Let's have fun. Let's check the next question. So question number 2. Show that QS is equal to x square root, my Lord, 1 over tan squared theta. Now, when you're looking at it like this, it generally doesn't make sense to you. But once you start working it out, things will start happening. Plus 1. Okay. QS. They want QS. Which is QS? Is that. That's what they want. QS. Okay. They're giving us a bit of a challenge. They want us to use our brains. So let's use our brains that the good Lord has given us. And let's use Sokotoa and sine or cos rule. Guys, I'm seeing a square root inside. What gives me a square root? Not the sine rule. Isn't the cos rule is going to give me a square root? There's two things that will give me a square root. If I use a cos rule, because it's a squared is equal to b squared plus c squared, or Pythagoras. Pythagoras also gives me a square or a square root. I don't know. Let's see. Okay, so they asked me to get that. If I say that square, let's look at this one here on the floor. I got this side. I'm looking at this triangle here. Okay, watch here. Let me highlight this triangle for you. Let me highlight the bottom triangle. The one on the floor, on the ground. Watch here. I got that side. I got that side. I got an included angle. And I need this side. So it must be the cos rule. So let's have fun. Bismillah. Let's go. Right. Pay attention now. Otherwise you're going to get confused. But how do I get all of that? Okay, I don't know. Let's try. Okay, so QS squared, I'm using the cos rule. QS squared is equal to QR squared plus RS squared minus 2 times QR times RS times cos 120. Yes or no? Yes or no? That is the cos rule. So let's go again. The algebra now. QS squared. What's QR squared? X over tan theta. X over tan theta squared plus RS squared. X squared. Minus 2 into QR. X over tan theta times RS, which is X, times cos 120 multiplied by cos 120 is 180 minus 60. Right, let's go again. QS squared, QS squared, X squared over tan squared theta plus x squared minus 2x times x. And this is a multiplication sign, right? So 2x times x is 2x squared minus 2x squared over tan theta times cos 180, the name will stay the same, cos 60. 180 minus 60 is in my second quadrant. Cos in my second quadrant is negative. Negative times this negative will make it a beautiful. Beautiful. We're getting there. I'm feeling the answer coming up. It has to. Watch here. So we did the cos rule here, right? We're still doing the algebra. Forget about the diagram now. Forget about the diagram. Let's concentrate on the algebra here. Because we want to get it from here to there. Let's go. QS squared. Let's see. See, 1 over 10 plus 1. There's the cos. Let me sort out the cos 60. Let me see how am I going to get it from here to there. So, okay. X squared over tan squared theta plus x squared over 1 plus 2x squared over tan theta. What is cos 60? A half. Yes or no? Isn't cos 60 half your special angle? Right. Now we need to get it from here to here. So let's do. This is all playing with algebra. You playing around with algebra. I know we're right. That's why I'm not even going back. Up to here, I know I'm right. Because I've got a 10 squared, I got a 10 squared, I got a 10, I got a 10. I can see things happening here. So we're playing around, we're having fun. QS squared is equal to, let's say x squared over 10 squared theta plus x squared over 1 plus 2x squared over 10 theta times 2. So it's times 2, right? Times 2. Now what's going to happen? This 2 here at the bottom and that 2 on the top will cancel out. We're still with the algebra. We're still with the algebra. QS squared is equal to, let's make this all over one denominator. LCD. What's your LCD here? 10 squared theta, am I right? 10 squared into 10 squared once, 1 times x squared is x squared, plus 1 into 10 squared is 10 squared. 10 squared times x squared is x squared 10 squared theta plus 10 into 10 squared 10 times. 10 times x squared is 10x squared. Okay, okay. We're getting there. We're getting there. Now watch what I do. Remember, the trick is to get to that. The trick is to get to that. Watch what happens. The magic begins now. We need to use algebra to get it from here to here. Guys, you have to be paying attention. You have to be paying attention. So QS squared is equal to, what's my highest common factor here? X squared. What am I left with? 1 plus 10 squared over 10 squared plus x squared is out, so I'm left with 10 over 10 squared is 1 over 10 squared. 1 over 10, sorry. Right, we're almost there. QS, let's simplify, x squared. Why am I getting 1 over 10? Where did I make an algebra mistake here? 10 squared into 10 squared once. 1 times x squared is x squared plus 10 squared, x squared, 10 squared plus 10 x squared out. 1 plus 10 squared. Oh, this is all over 10 squared, sorry. It's all over 10 squared. So just give me this here, plus 1. Right, wait. It's all over 10 squared. So I'm left here with 10 theta. Right, there we go, 10 theta. Okay. Now watch what I do. Okay, now I hope you got this down. Right, guys, it's such a long problem in terms of the algebra. I'm not going to be able to redo all the algebra. So if you miss the algebra, you're going to have to re-watch it and go back to rewrite it, because I just need to get to our final answer here. So I'm moving over to the side now. Remember, I need to get to that. Watch here. Watch here. It's happening. It's happening. That's 1 over 10 squared theta. This belongs to all. Plus 10 squared over 10 squared theta. Plus 10 theta over 10 squared theta. Algebra. QS squared is equal to x squared into 1 over 10 squared. There's my 1 over 10 squared. Plus 10 over 10 squared is 1 over 10 theta. There we go. 1 over 10 theta. Can you see? Copy and paste. It's happening here. 10 squared over 10 squared is how much? 1. Therefore, QS, moment of truth, is the square root of this whole thing. The only perfect square underneath here is x squared. So you pull it out. That's how you get the x outside. Here's your final answer coming up. Therefore, QS is equal to the square root of x squared is x. And then you are left with everything else inside. 1 over 10 squared theta plus 1 over 10 theta plus 1. Boom. Done. All you did, I knew it took a lot of concentration. The only thing you did was apply the cos rule. And you made QS the subject of the formula. That's all you did. Yes, a page of calculation. But that page of calculation didn't take mind work. It took algebra work. This was pure algebra, guys. After substituting into the cos rule, the algebra took over on autopilot. But you had to make sure that your algebra was correct at every point. We only used one triangle. We only used the triangle on the floor. We use QR and we use X. What was it? X tan theta, ne? And we use X. That's all. And we use 120, the included angle. So your last side squared was equal to that side squared plus that side squared minus 2 times the product of those two sides cos of the included angle. The cos rule. If you didn't get this one or you didn't get your algebra right, you made a mistake somewhere, practice on this one, re-watch this, go to YouTube. Remember, it's being recorded. You can go home, watch it over and over until you get it. How are we doing there, onliners? I know it was a rough one. But this was your final exam. This one came out of your final exam. So I'm not doing something from Mars. You're going to Lulu. Okay. You are seeing stars. You are seeing stars. All right. All right, let's do this. Let's do this. We got 10 minutes before break. We got 10 minutes before break. Let's start with, let's finish the analytics intake. Come, let's switch to something totally different. Right. Let's do something a little bit lighter. Let's do one analytics component. Let's do one analytics component that will take us to break. We come back, we're going to crack Euclidean. Right, let's go. I know your brains are fried. Take a screenshot, take a photo. It is long, but it's just manipulating your algebra after the formula has been issued. Okay, let's go. We're at the end, guys. It's only 10 minutes left, so that's why I'm saying let's do this here. This is quite easy. Let's just do a quick recap here. Right, take this diagram down, guys. Take this I won't give you a hectic diagram. I'll give you a diagram that looks like that. Like that. And like that. There we go. I call that angle there, angle theta. I call this one angle beta. 0, x-axis, y-axis. Triangle PQR, P 4 and 30, Q minus 10 and 2, R minus 6 and negative 12. Okay. Right, question number 1. I want the gradient of PR. Question number 2. I want the equation of a line parallel to PR passing through Q. Question number 3. Find angle beta. Question number 4. Find angle theta. The last one. Let's PQRS. Find the equation of PS. Find the equation of PS if PS is perpendicular to QR. Right. Now, guys, you guys are going to get 2 analytics questions, very similar. One, 20 marks, 20 marks, or 40 marks. 40 marks on analytics, 20 marks on data handling, 50 marks on trigonometry, 40 marks on Euclidean. There's your 150. Guys, oh yes, I forgot to tell you, just make a note there for under trigonometry, learn the proof of the area rule, sine rule, and cos rule. That's bookwork that you'll get from your textbooks. Just say learn the proof of area rule, sine rule, cos rule. And that's mahala marks, that's free marks, jam, marks for peanuts. Just memorize it. Please, guys, don't take chances in your exam. Don't go and write the proofs on your hands and then lick it off and while you're writing. And I know girls, some of you girls, you put it in your scarves. I know it goes places. Under your kufia, you make some of you write it on the desks before, and then you know you write it quickly in your papers and erase it quickly. I know all your tricks. I'm not saying I did it. I'm just saying I know, I saw people doing it before. Some of you write it on tissues. Teacher asks, you were fine this morning. All of a sudden the sinuses are hitting you and you just... Yeah. Those cheat sheets go places. Come, guys. Okay, so we got 7 minutes. Let's finish this. I say, do you guys want to finish this and then go for break? Break first. Lunch. Somebody, anybody? The gradient of PR, so the M of PR, let's do the M of, let's answer, let's see how far we get, right? The M of PR is equal to Y2 minus Y1 over X2 minus X1. 30 plus 12 is 42 over 10, which is equal to, what, 2 goes into there, what's it? 21 times 21 over 5. You'll just double check my algebra, right? There's my man who always corrects me. So you'll check my algebra, 21 over 5. So the M of this line is 21 over 5. That's your first 3 marks. We all okay with that? Easy stuff. Next one. The equation of a line parallel to PR, but passing through Q. So watch here. So basically, what are they asking you for? A line parallel to PR, passing through Q. So obviously, the equation, remember they want equation, so y is equal to mx plus c. So y minus y1, remember I taught you this formula yesterday, m into x minus x1. Right. So y, we have to use q's coordinates. Y minus 2 is equal to m, which is 21 over 5. It's the same gradient, into x plus 10. So y minus 2 is equal to 21 over 5x plus 21 times 10 is 210 over 5. Here's your final answer coming up. Y equals 21 over 5x. 210 over 5 plus 2. 210 over 5 plus 2. 44. And there we go. That's your final answer for number 2. So you got 3 marks there. You got 4 marks here. 3 and 4, you've got 7 already. We're almost there for break. We're almost there for break. Question number 3. Find angle beta, angle of inclination. So tan beta is equal to the M of line PR. So tan beta is equal to 21 over 5. So beta, obviously, shift tan. Let's do the answer for number 3. Shift tan 25. Beta is equal to shift tan 21 over 5, angle of 76,6. So you go here and you put 76,6 degrees. Another 3 marks. 4 and 3, 7 and 3 is 10. 10 marks already in the bag. We need to do question 4 and 5. It's lunchtime now. I know your brains are fried. We'll do number 4 and 5 after break. After lunch. We're giving you 45. I'll see you guys here. I'll see you guys back here 20 past 1. 20 past 1, you got a 45, 50-minute break. Last session. See you guys. See you guys for round 3. Onliners, enjoy your lunch, enjoy your lunch, enjoy your lunch.
In the year 2000, Awqaf South Africa was pioneered as an institute of Waqf and the empowerment of communities. South Africa faces a diverse set of challenges with a high unemployment rate and a stark divide between rich and poor, where electricity, hospital care and water shortages plague communities and where lack of education hinders progress. Awqaf South Africa is a catalyst for change. As a charitable endowment receiving organization, Awqaf invests endowment funds wisely and ensures that only the income generated from investments is used to fund a variety of community development projects. We are excelling in all that we do with the highest standards of ethics, integrity, and sincerity of purpose. From masjid development, imam empowerment to sports development, orphan support, food security, and surgery support, Awqaf South Africa is paving the way by investing in the future of communities and uplifting generations to come. Awqaf South Africa, creating a legacy.
You say any type of way. It's gonna be like yourself.
You're gonna speak closer. Yes.
We are live at South Peninsula High School here in Plumstead in Cape Town. With me is Isra, Mosaval as well as Khali, they will be talking to us. Okay, just to say their name formally so that their family members can recognize them. Of course, they know their names or something like that, but just to make it a little bit more professional, I've got Skayla Adams, I've got Amani Khali, as well as Miss Isra Mosaval, who will be chatting with us now. Starting with you, Isra Mosaval. How are you feeling today?
So at first, when I arrived, I was actually very excited because I was about to learn new ways
You're
to.
saying that you were excited. Where's the excitement?
No, it's just the middle of the day. It's now we are almost about to get to the graveyard shift, and that's always the most tiring part of these types of workshops because you're so tired. But like I said, I was excited because at school, like we are always learning the same methods and things like that. So
Yes.
it's always nice to meet different people and see their approaches because there are many ways to solve things in maths, and it's always fun to learn the different types of ways.
I'm getting a call online that you're speaking very softly. So
Oh,
if you can,
okay.
a
Is this
little
better?
bit lift, yeah, that's a
Okay.
little bit better.
Okay.
That's according to the people online, but I can hear you on the ground. Skayla, I believe that you are from here in South Peninsula High School. How have you found actually the workshop?
Okay, so like coming in, I didn't know what I was going to like expect, but
Yeah.
I think that encountering with Mr. Muhammad, I think it was very helpful, and it will like help me in different ways in mathematics so that I can grow to be the person that I really want to be. in
How
the
have you
subject.
found Mr. Kota? Because he is got a different personality, especially when that graveyard shift comes, he will know how to keep you all
Awake,
guys,
yeah.
awake and so on.
I think what is really important is that he doesn't just like teach us math, but it's also the importance of like bringing in jokes just to like keep us alive. But it also shows like he's like enthusiastic about like learning and teaching us. So I think that's very important.
And then coming to you, Amani Khali, I believe you also from here at the South Peninsula High School. Yesterday I interviewed two boys, Johnson as well as Olivier, who were standing with me here on this actual part. Spot that we are standing on, and a lot of people online were like, where are the girls? We want to see the girls. And then we brought up yourself as well as Skayla and Isra. How have you found the workshop?
I found this workshop really helpful, especially because Mr. Muhammad, he has different approaches as to how he solves sums, and it's quite different from what we've learned here at SP, but it's very refreshing to see other people's approaches on it, and it is quite helpful in some ways.
It is quite helpful in some ways,
Yes.
and that is Amani Khali talking to us here. Now, I would like to know from you, girls, in the next 10 years or 5 years, where do you see yourself?
In the next 5, okay, maybe 7 years, can I say 7 years?
Yes, you can.
In the
It's up
next
to
7 years,
you.
I see myself studying to become a prosecutor, maybe married.
We are in trouble.
And possibly owning my own business, especially a clothing line because I love fashion.
Oh, you love fashion?
Yes.
And you want to be a prosecutor?
Yes.
We need to discuss that one because fashion designers can be quite deceiving. And now, then, coming to you, Skayla Adams, where do you see yourself? She said in 7 years' time she wants to be a prosecutor as well as a fashion designer. And yourself?
I think I would also say 7 years because realistically I wanted to study law, but I think that aligning with my personality, I would love to go into psychology. I feel like helping people,
Yes.
it will make me feel good about myself, but also character development is really important in like, just being in the world that we have, and opening minds, but also being open-minded. So.
You sound like a potential psychologist right there. And we've got Isra Masaval now, who will be telling us in the next 5 to 10 years, where does she see herself?
So in the next 5 to 10 years, I see myself as an educator, or perhaps in the medical field like nursing or more specifically midwifery. So I am torn between those two career paths. The reason why I chose education is because I just love helping people. And when I see their face light up, when they understand something that I showed them, it just brings me like some sense of fulfillment, and I really love that feeling. And also, I know that a lot of people might not agree with this, but I also see myself starting a family.
Here we go. I'm enjoying this.
It's a family.
Yeah.
And I know like with nursing that might be hard, but I do feel like I can do it. And anything is possible if you really put your mind and your heart to it. And
I think it's all about being realistic because,
Yes.
in as much as you guys are still students, but
Yes.
you've got to think about the future,
Yeah.
and which is why Awqaf SA is here to make sure that we help shape that future. And I'm glad also you made mention that you'd like to be an educator, because last time we were here at SP, we spoke to some students, and absolutely none of them mentioned, they mentioned that they want to become engineers, they want to become architectural sciences or something like that, but none of them mentioned that they want to become teachers, which prompted or which led to Mr. Baker saying that we actually do need good, pure maths educators.
And another thing, like with like an educator, like a lot of people kind of they will not see it as their first choice. But I feel like educators are like the people that mold us, and they can really influence our future. Because I still remember my primary school teachers because of the things that they would say or how they would help me, and that's just for me.
Just before I let you go, girls, 1 minute, 1 minute, 1 minute. I believe there are SP students who are currently watching you online, or those who may be doing grade 8 or grade 9, or even your primary school students, you know, who are aspiring to be doing pure maths, but they don't think they don't think they have the potential. So what would you say to them?
I feel like everybody has potential. They just are too lazy to unlock that potential. And with maths, it's not something you're going to get right the first time you try it. You have to work constantly to improve it. So you can't say, I'm so bad at maths, I want to switch to method, without even giving it a chance, because you are closing that door before you even were willing to wait for it to open.
And now to you, Scalar Adams, what will be your message to them? And please lift your mic a little bit up.
I feel like I can agree with Israel is saying. It's like you're narrowing yourself down, or like you're limiting yourself already with your mindset. I feel like mindset is very important. If you go into something with a positive mindset, you will get a positive result. If you're going to go in with a negative mindset, there will be a negative outcome. So it all starts with you. It all starts with your mindset, and not giving up and just pursuing until you do get to your objective.
Beautiful. And last but not least, we've got Amani Khali, who will be giving that final motivation.
So my answer is quite similar to Isra's and Skylar's. I feel like you don't need to be intellectual to understand math, but you just need to practice it constantly. And that's something that every educator preaches since primary school till high school and through university. Because once you practice something consistently, you'll be able to achieve it 100%.
And that was Amani Khali as well as Skylar Adams and Isra Masaval talking to us, saying that if you put everything, or if you apply your mind into everything you're doing, then you are bound to pass it by flying colors. We've got a huge motivation from all of them here today with Rabia, Isra rather. You know, I'm used to Rabia Mosaval. I work with Rabia Mosaval. So when I just see the same name, I just think of Rabia Mosaval. But Isra Mosaval telling us that in the next 7 years, she sees herself, you know, as an educator as well as a family person who will be looking after, you know, her husband, inshallah, as well as her 2 kids. I'll be saying 2 kids for now. And that's it from me. It's Khalid Kungane Kivaspadi, live at South Peninsula High School with Skylar Adams, Amani Khali, as well as Isra Masaval. We will try and update you as far as the competition is concerned. But for now, that's it from me. Thank you very much for tuning in.
Good morning, everyone. My name is Risa Makaila, and I am the winner of the 2022 Awqaf SA Online Metric Maths Workshop competition. Yeah, that's quite a mouthful, but we'll get into that later. I just wanted to make this short video to encourage and congratulate the metric class of 2023 for making it this far. We have been in the schooling system for 12 years now, and it all comes down to this. We are at the end of the year, which means that finals are starting soon, and the time between now and finals is very crucial in that you have to work hard and make sure that you are comfortable with what you've been doing this whole year and that you're confident walking into that examination room. And I can say confidently that by attending these workshops, you are bringing yourself one step closer to reaching your dreams, because they will do wonders to your marks only if you actively participate and ask questions. So please just make sure that you use them wisely, because they can really help a great deal in your marks. And having great marks in metric comes with a lot of great rewards. And speaking of rewards, Awqaf SA is hosting a competition for the participants of these workshops. So you will have to send your final results and your June metric results to them next year in January. But you don't have to worry about that right now. Just be mindful of the fact that there is a competition that will be hosted by Awqaf SA. If you registered for these workshops, you will be sent an email after the final results are released. But just make sure that you enter the workshop when that happens. And finally, I just want to say good luck. Just grind. This is the final push. You're almost there, and I believe in you. You will make it.
All right, so that was at 11. Let's check our comments coming in. Guys, are you in? Where's all our peeps? Where's our peeps? There we go, here we go, here we go. We are back online, guys. Thank you very much. I hope you enjoyed your lunch. Okay, let's finish up where we stopped. We found angle theta. Let's go back. Remember, we're going to do this. And then I want to go into, you want to do some trig graphs. We'll do one question from the past paper on the trig graphs. And then we go into Euclidean. Okay. Remember, we finish off at 3 p.m. on the dot. Let's get started. Find angle theta. Let's all get back in. Okay. All right, now pay attention here, guys. We're looking for angle theta here, and angle theta is in the air. Pay attention to this. Let's get our whiteboard up. There we go. We're answering question number 4. We are answering question number 4. Find angle theta. Now, if this angle here is... Now, what you can do, come I show you a nice way of finding angle theta. What you can do is draw another x-axis there. You can draw a false x-axis there. Now we know that this line is parallel to that. So if that is 76,6, then this angle is 76,6, the small angle. That angle of inclination. You can call this angle theta 1 if you want to. And then what you can do is find this big angle here and call that angle theta 2. So we got angle theta 1, angle theta 1 is equal to 76,6. Right? That's a small angle. This big angle here, tan of angle theta 2, is equal to the gradient of line QR. So tan of angle theta 2 is equal to y2 minus y1 over x2 minus x1. That is equal to, let's go to our calculators, 2 plus 12 is 14 over negative 4. So theta 2 is equal to, now we go, shift tan 14 over negative 4. We get minus 74,5, 0.05. But this is an obtuse angle, greater than 180. So we say 180 minus 74,5, or we add 180 to it. To get the obtuse angle, an angle greater than 90, we're going to say, so therefore angle theta 2 is equal to plus 180, 105,94. Right? What's happening there? Why is my screen? What's going on? If I put a tick there, nothing's happening there. I'm getting a bit of a delay. What's going on? What's going on there? We were okay. Think we're getting that delay again. Just check. So it's 105,9. So therefore angle theta is equal to 105,9 minus 76,6. So 105,9 minus the 76,6, you get 29,34. 29,34 degrees. And there we go. Basically, it's a very simple concept. We're just saying big angle minus small angle. What are we doing? We're saying big angle minus your small angle. Let's erase all of that. So let me just write it out for you here again. So theta is equal to angle theta 2 minus angle theta 1. Theta 2, your big angle, 105,9, minus theta 1, your small angle, 76,6. And then your answer is 29,3 degrees. And there we go. Big angle minus your small angle. Especially when it's in the air. Especially when angle theta is hanging in the air and it's not against your x-axis. And let's wrap up with the last question. Find the equation of PS if PS is perpendicular to QR. Find the equation of PS if PS is perpendicular to QR. So let's draw PS in. Let's draw it in a different color. PS, that's the line you want. They're telling you it's 90 degrees. It's perpendicular. They want the equation of that line. So we got a point. We're only short of the gradient. But we can find the gradient of QR. So this is the way we do it. Let's answer the last question. What was it? Question number 6. So we say the M of QR is equal to y. Didn't we find the M of QR? What was it? 14 over minus 4, I think. The M of QR was 14 over minus 4. So the M of QR, if we simplify that, that's minus. 2 goes into there 7 times, 2 goes into there 2 times. Therefore, the M of PS is equal to 2 over 7. Change the sign, flip the fraction. Why? Because QR is perpendicular to PS. You must put the reason. So change the sign, flip the fraction. Why? Because the product of the two gradients must equal to how much? negative 1. Very good. The product of the two gradients must equal to negative 1. So therefore, the equation would be y. Can you see how much we're using this formula? Y minus y1 is equal to m into x minus x1. Right, work it out. Substitute it. Onliners, how are we doing? You understanding what we're doing? Excellent. Let's go, guys. Let's go, let's go, let's go. So y minus 30 is equal to 2 over 7 into x minus 4. I'm using point P's coordinates 4 and 30 for x and y. Why? Because it lies on the line. So y minus 30 is equal to, let's multiply this out, 2 over 7x minus 8 over 7. So y is equal to 2 over 7x minus 8 over 7. Go to your calculators. Minus 8 over 7 plus 30 is 202 over 7. And there we go. That's the equation. That's the answer to your last question. Okay. Are we all okay? You all understand? We good? The algebra is right. The algebra is right. Okay. Let's start with trig graphs. Let's start with your trig graphs. Now, very important is for you to understand the amplitude, the period of the graph, the domain, the range. And the shift left or shift right, shift up or shift down. So let's go. Let's start with trig graphs. Let's start with trig graphs. Okay. I tell you to sketch f of x is equal to sine 2x. And I ask you to sketch g of x is equal to cos x minus 45. Right, I ask you to sketch these two graphs. Let's go and sketch it. And obviously they tell you from minus 90 to 360 degrees. Okay, so let's go. Important to remember that a sine graph, S for sine, S for starts at 0. C for cos. The cos graph starts at the height, so it cuts first. And just remember, the tan graph has got asymptotes. The tan graph has got asymptotes. Where are your asymptotes? 90 and 270 for a standard graph. Right. What's also important to remember that the number in the front gives you the maximum and the minimum. So the graph will be from +1 to -1. It also tells you the amplitude of the graph, maximum height. This here is the domain, not the period. That's the domain of the graph. This value tells you two things. 90 degrees divided by that number gives you the step of the graph. After how many degrees will the graph make a change? I'll show it to you now when we do it. And this value also tells you the period of the graph, 360. For sine and cos, we say 360 divided by that number is equal to the period of the graph. That's for sine and cos. For sine or for cos. For tan, we say 180 divided by that number is equal to the period for the 10 graph. So that's how you analyze an equation. Very important for you to analyze an equation before you even start. Negative here, when it's x plus or negative, plus or minus here, that means shift right. Negative is shift right. Positive means the entire graph shifts left. So it's important you take all this down because it's important that you know what each component means. If you don't know, you won't be able to sketch, neither will you be able to determine equations of these graphs or answer the theory with regard to these graphs. Okay? Good. I know it's rough, but trust me, we only got about an hour and a half, hour 25 minutes. Before you know it, today is done. Because I even want to do the one that from the past paper for you to be able to do this, and then I want to go straight into Euclidean. If we have enough time, we'll do probability. Okay. We're back here. Right? Let's check. Our online is all good. Online is all good. Right, here we go. Now I'm erasing all this that I wrote because this is all important stuff that we're going to need for these graphs. Okay, here we go. Right, so first question, question number 1, sketch the graph. Question number 2, we want the amplitude of f. We want the period of f. The domain of G. And for which values of x is f of x? Okay, I see it's going there into the corner. Let's do number 5 there. Where is f of x greater than or equal to g of x? Right, question number 1, let's sketch the graph. The first thing we do is we draw our, let's draw our axis. What's going on there? Right, that's your y-axis, that's your x-axis, that's 0. 90, 180, 270, 360, minus 90. There we go, from minus 90 to 360. Right, let's draw the sine 2x graph. So picture this as a swimmer or picture this as a dolphin. So the sine swimmer starts at 0. The sine starts at 0. So we're going to go 0 up because it's positive. We're going to go up to 1 and down to minus 1. This swimmer is going to start here. That's your swimming pool. He's going to start up. He's going to go up. But you need to find out the step. So the step 90 divided by 2 equals 45. That means at every 45 degrees or at every 45 meters, this swimmer is going to make a change. 45. So he's going to go up, jump up in the air, turn at 45, hit the water, come down, turn, hit the water, go up, hit the water again, come down, stop there. Now you continue this on the other side. So he comes down this way. From here, he comes down, turns there, stops there. So the sine 2x graph, if we draw it, this is what he looks like. He goes up, up, up. He turns. He hits the water. Comes down. He turns. He goes up. He turns. Hits the water. Turns. He stops. And we continue the pattern on the other side. And there is graph F. Are you all with me? Why 45? Because we take 90 divided by 2. 90 divided by 2 gives me the step of the graph. After how many degrees he makes a change. The next graph is our cos graph. The maximum value is also 1, but he's a cos graph. So he starts at the height. But instead of him starting at 1 or at 0, he starts 45 degrees to the right. So he starts here on the top. So he comes down. So he goes down, 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 down. He cuts. Next 45, he turns, cuts, goes that way, come down that way, and up, and continues on the other side, down. Basically, it's almost the same graph, bruh. The sine 2x and the cos x minus 45. Check, your sine 2x graph went up, turned. Negative means to the right. Okay, so there we go, 45 degrees to the right. He starts here on the top. Every 45, so no. Wait, remember something. Wait, let's go back. Yes, he starts here. But now remember the original cos graph. The original cos graph is 0, 90, 180, 270, 360. So that means the original cos graph starts here at 1, cuts at 90. Cuts at, he comes down, cuts at 90, turns at 180, cuts at 270 and stops. So now he's starting 45 degrees to the right. So it's still, so 45 plus 90, or 90 plus 45 is 135. That means he comes down here. Instead of him cutting at 90, he's going to come down. He's going to come down and cut at 135. Instead of him turning at 180, he's now going to turn at 180 plus 45 is 225. Instead of him cutting at 270, he's going to cut at 315, 45 degrees later. And he's going to stop. And on the other side, instead of him coming down and cutting at minus 90, he's now going to cut at minus 45. And he's going to stop there. And there we go. That is graph G. In fact, he's going to go a little further up here because he needs to stop at 360. So he's going to go up, 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 up at 1 and 360. That's where he's going to stop. So this is graph G. Right. There's your two graphs. Sketched. The amplitude of F. F's amplitude is how much? 1. The period of F. How do we calculate period? I gave you a formula. We say 360 divided by that number is equal to how much? 180. So the period of F is 180 degrees. Now, where are the two graphs greater than or equal to each other? Where are they above? Where is this graph above that graph? Sure, it's above there. No, F. Let's look at F. So F is above, it's above there. F is also above here. And that's it. That's where F is above graph G. So we need to find out where do they intersect. We can't read it off the graph because our graph is not drawn to scale. So this is where it comes in again. Watch here. Remember we did general solution. This is where general solution comes in again. So it's sine 2x equal to cos x minus 45. Do you remember that? Right? So now we go back. Where are the two graphs equal? So where is sine 2x equal to cos x minus 45? So what did we say? Sine 2x is equal to sine 90 minus x minus 45. Yes or no? We cancel that, cancel that. What do I have? 2x is equal to 90 minus x plus 45 plus k times 360, where k is an element of integer. See where general solution comes in? 2x plus x is 3x is equal to 135 plus k times 360, where k is an element of integers. So x will equal to 135 divided by 3 is 45 plus k times 120, where k is an element of integers. Now let's say k is 1. So 1 times 120 is 120 plus 45. That means this value, where they first meet, is x is equal to 45 plus 1 times 120 is 120, which is 165. That means this value here is 165 degrees. Can you see how general solution helps us on the two graphs? So there we go. And what do you think this value here is going to be? Let's try it again. If I put 2 times 120, if k equals 2, 2 times 120 is how much? 240. 240 plus 45. This value is 285 degrees. Right? If I said k was equal to, let's say k was equal to 2. 2 times 120 is 240. 240 plus 45 is 285. So the point where the two graphs meet is 165 and 285. So this is where the graph is bigger than where the one graph is above. So your answer for this question is x less than or equal to 285, but greater than or equal to 165. That's your answer for the last one. And how did we get that? We got that using our general solution. Do you now see the importance of general solution? Right. Now I'm going to give you one from a past paper where now they're going to give you the graph, and you need to give answers for it. Right. It's worth 8 marks. Right. What was the domain of G? From minus 90 to 360. The answer to this was x less than or equal to 285, but greater than or equal to 165. I got my 165 there, and I got my 285 here. When I said 45 plus 1 times 120, and that gave me 165. And then I said 45 plus 2 times 120. That was 240. That gave me my 285. Okay? 120 times 2 is 240 plus 45 gives me 285 and the 165. That's your two general solutions. Right. let's give you this. Watch this. Here's the one from the past paper. So they give you that. Take it down. Don't worry about the time, guys. Let's just worry about, can we finish all the work, and are you familiar with whatever is going to be coming out? Right, here goes. So, they give you 0 there. They give you +1 there. They give you -1 at the bottom. Take this one down. That's 90. That's 180. And, okay, so they give you a graph at, oh, this one also. They give you here at 45. Watch here. So they give you a graph going up like this. Take this one down with me. That's 135. Comes down, 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 down. Turns here. Goes up there. Then you got -45, which is there. Graph comes down there. Turns there at -45. -90. Cuts there. Goes to -135. Goes up till there and 1. And stops at -180. Right, there we go. Yeah, that's the first graph. The second graph that they give you on top of this is a graph that goes here, comes down, cuts between, whoa. Let's see, it cuts somewhere there. And then it cuts both these graphs at ends. So, okay, so it goes like that. Comes down here, turns here and stops there. And then it comes down from here and cuts at -120. So 120 is there, -120. And there we go. That's your two graphs. The sketch graph, okay, this is what they give you. They tell you f of x is equal to sine ax. That means you need to find the value of a. And that must, and they don't even label it. They don't even tell you which is f and which is g. And they tell you g of x is equal to cos x minus b. Cos x minus b. So you can clearly see this one is with a period shift and this one is a complete shift to the left. Obviously, this is 0. It starts here and turns at 45. So this must be graph F. That must be graph G. Because it's only a sine graph that will start at 0. Let's look at the questions. Question number 1, find the values of A and B. Find the values of A and B. Now A is easy because this is 45. It's supposed to go to 90. It's turning at 45. So, right. So 90 divided by A, to find A. 90 degrees divided by A is equal to the step of the graph, which is 45. Remember the formula for the step? 90 divided by that value is equal to the step. So let's flip it over. A over 90 is equal to 1 over 45. A equals times 90 times 90, 90 over 45. What is A equal to? 2. A is equal to 2. So let's go to A. Let's take that out and let's put 2. How did I get it? I got it using that formula for the period of the graph. 90 divided by the A value is equal to the step. Here the step is given to us at 45. The graph makes its first change. It goes up, 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 and it turns at 45. So 90 divided by A is equal to the step of the graph, 45. And then we just solve for A. Now we know that's minus 45. You can clearly see that this graph here, the cost graph, has shifted. The normal graph would have started at 1. It's starting at minus 45. So, it has shifted 45 degrees to the left. So, it must be cos x shift to the left is plus 45. That's your actual equation. They're telling you that the equation, now they're trying to trick you. So watch here. They want the value of B. B is not 45. Remember, minus B. Minus B is equal to 45. B equals minus 45. Be careful, important. Minus B in this case. Remember, positive means shift left. So the actual equation is x plus 45. So if I put cos x plus 45, there we go. Now minus b is 45. There we go. Minus b equals 45. B equals negative 45. But the equation is x plus 45. So g of x is equal to cos x plus 45. Right? That minus will change this one. Okay, because it shifted 45 degrees to the left. And there we go. There we go, guys. We've answered the first question. B is not 45. B is minus 45. Right, let's go. Let's erase. Let's see what the next question is. The coordinates of C, a turning point on G. The coordinates of C, where is point C? Actually, C turns here. It comes down like this. It turns and it comes up. So that point there is point C, a turning point. Okay, so what would the coordinates there at point C be? Because it's a turning point, the y value will be minus 1. Because it's a turning point, so question number 2, they want the coordinates of C, a turning point on graph G. So we know that the y value, because it's a turning point, the graph's going to come down, it's going to turn here at minus 1. That's the minimum value of the graph. Now we need the x value. So all we do now is we know y equals cos x plus 45. So we got the y value, minus 1. So cos x plus 45 is equal to minus 1. So shift cos minus 1, shift cos minus 1, we're solving for x, is 180. So x plus 45 is equal to shift cos minus 1 is plus minus 180 plus k times 360, where k is an element of integers. X is equal to 180, we can say 180 minus 45 plus k times 360. So x is equal to 180 minus 45 is how much? 135 degrees plus k times 360, where k is an element of integers. So that point C is 135 degrees. I just want to double check here. That's 4590. No, but then this here would be 145. That point is here slightly to the right. What if I took minus 180 plus 360? I still get 180, so it won't be 180. This here would definitely have to be 135 degrees. X is equal to 135 degrees. That would be the other turning point of this graph. Okay, can you see what we did? All we did, we equated the original equation. We equated the original equation to minus 1, the minimum value. And then all we did is we solved for x. Are you guys with me? Right. Next question. Where is f of x times g of x greater than or equal to 0? Where is f of x times g of x? Where is f of x? So that's point C. Let's go back again. Question number 3. Where is f of x times g of x greater than or equal to 0? Right. In a situation like this, to get an amount greater than 0, to get a value greater than 0 means positive. So a negative times a negative is a positive. Or a positive times a positive is a positive. Yes or no? Grade 11s, you with me? Right. Solution 1, solution 2. So where is f negative? Let's first go to solution 1. Where is f negative? F is below your x-axis between 45 and 180. Let's do it in black. Where is f negative? F is negative. It's below your x-axis between 45 and 180. Where else is f negative? Let's look at f. F is negative between minus 90 and 0. Between 0 and minus 90. Right, this is where f is negative. You just draw it as number lines. Now, where is g negative? Where is g negative? G is negative. What is the halfway mark? In fact, here, guys, g is negative. That c's coordinates had to be the halfway mark between 45 and 90. Look here. Look here, look here, look here. Can you see here at the back? Can you see here at the back, they gave you 120 degrees. That means this graph shifted between minus 90 to minus 120. How many degrees here away from it is it? 30 degrees, am I right? It's 30 degrees. From minus 90 to 120, it's 30. That means C's coordinates, just go back to that previous one. C's coordinate, this was 135. Plus 30 degrees. So C's coordinates is 165 and minus 1. Because can you see it moved 30 here? So it had to go 30 here. Actually, it's not 135 plus 30. Sorry. Wait, I'm a bit. It's 180 minus 30. Sorry. It's 180 because can you see the graph move 30 degrees here? So 30 degrees from 180 is 150. So C's coordinates, guys, let's just quickly go back. Quickly go back to C. C's coordinates. C's coordinates is 180 minus 30. C's coordinates here, 180 minus the 30. Where did I get the 30 degrees from? Here. From minus 90, the graph should have cut at minus 90. It's cutting at minus 20. So it's 30. Okay. There's something happening here. There's something happening here. Yeah. I know they're going to come up with questions. Your cos graph is actually not even 45 because the turning point is here. Look here. This is what indicated to us that the graph. Look, I'm not working through a memo, so I'm just looking at what we have. The turning point is actually not there. The turning point is here. So and how do we know that the graph is starting at minus 30? Because of this. I'm going to circle it here for you. Watch here. This gives us a clue that the graph moved from minus 90 to minus 120. Minus 90 to minus 120 is how many degrees? 30 degrees. So the graph shifted 30 degrees, not 45. That means our answer here, guys, is incorrect. It's fine. You are allowed to make errors. As long as you fix your mistakes. So let's go back. That's cos x minus b, which is cos x. It moved 30 degrees to the left, plus 30. So minus b is equal to 30. So b is equal to minus 30. So go back to that previous question. Just change. A we got as 2, we know. A is 2, b. Move 30 degrees. It's minus b is equal to 30, so b is equal to minus 30. So that means we go back here and we change that. So it's x plus 30. X, let's go back, plus 30 degrees. Right, we just had to correct our course quickly before we fail it. Right, let's go. So what do you think that this value is? If everything moved 30 degrees to the left, this graph would have come down and cut at 90. It's now cutting 30 degrees to the left. So what do you think this value is here? 60 degrees, yes or no? 90 minus 30, right? Let's double check. Let's double check. Let's double check. Okay. We're looking at where G is negative. So where is G beneath your axis? Graph G is beneath between there and right up till there to 180, right? Again, minus 30 plus 90 will give me 60 degrees. So that is correct. That value there is 60 degrees. And that's 180. So from 60 to 180, you can see it's below. 60 to 180. So that's 45, so 60 is somewhere here. 60 to 180. Where else? Is there another place where it is below? Yes. From minus 120, this graph went till 180. So let's go here. My word. So we don't have enough space here. I just want to erase this. That we had to go now from minus 120, it's below here, minus 120 to 180. That's minus 90. That's minus 120 to minus 180. Minus 120 to minus 180. This is where graph G is negative. Right. Where do these two overlap? Remember, multiplication or division means overlap. Where do these systems of number lines overlap each other? Do they overlap here? No. Do they overlap here? No. Do they overlap there? No. Where do they overlap? You can clearly see 180 to 60. That's also 60 there on the top. So here's your first inequality. X less than or equal to 180, but greater than or equal to 60 degrees. There we go. That's your first inequality. That's your first solution. Take that down. That is where F is negative and where G is also negative. and we see where they overlap. Now we have to do the second one. Let's see if you guys can do the second one. Where is F positive and where is G positive? Draw your number lines and see where they overlap. Do the second solution on your own. If you can get the second solution right, it means you've understood the concept. Look where F is above your x-axis and where is G above your x-axis. Put your two number lines wherever they overlap. Those are your solutions. Let's do the second one. Let's see if you guys can. You'll understand it very clearly when I do the second one. Right. What was this one's coordinates? This one was 150. C's coordinates was 150 and minus 1. I'm just writing it in there. Okay. That was solution number 1. So solution number 1 was x less than or equal to 150, but greater than or equal to 60. That's your first answer. Now let's do the second solution. Where is F positive? Where is F positive? F is above your x-axis. How many points? From minus 180 to 90. Let's go. From minus 180 up to minus 90. That's where F is positive, right? F is above your x-axis there. It's also from 0 to 90. From 0 to 90. You all understand that? There where I put a tick. Do you all understand that what I drew? Where is F positive? Right, now where is G positive? We're doing solution number 2. We're doing solution number 2. Where is G positive? G is above from minus 120 to 60. So from minus 120, let's say minus 120 up to 60. From minus 120 up to 60. That's where G is positive. This is where G is positive, guys. And the first one is where F is positive. Right. Is that where we stop? No. We got to see where do the two overlap. Because they say multiply or divide. Where do they overlap? They overlap here. I'm going to do it in black. You can clearly see that piece there and that piece there. So they overlap here. And then this piece here and that piece there, they overlap there. So that means X, here's your answer, less than or equal to minus 90, but greater than or equal to minus 120. That's there. And they overlap here between 0 and 60. X less than or equal to 60, but greater than or equal to 0. So you got 3 inequalities as your answer. You got your first inequality from solution 1, and you got 2 inequalities from solution number 2. And there's your answer. Done. What's the time? It's 10 past 2. I'm going to give you a 7-minute bathroom break. We're going to come back and we start with Euclidean. So you guys just need, I know you guys, your brains are fried. I know it. I know it and I can see it. Relax. You're going to get it. I promise you, you will get it. Let's take 7 minutes. We come back in 7 minutes. Get some fresh air. Wash your face. We're going to crack Euclidean until the end. Boys and girls, take a 5-minute break. See now, kick that O out.
Huh?
Kick this O out.
Oh, okay. Done.
Screen up? Not yet. Right, there we go. Take this down, guys. I just want to explain to you this concept one more time. For those of you who didn't get the last one. Again, I'm telling you, it could be f of x times or it could be f of x divided by g of x. It's the same thing. Right, now watch. Let's do this quickly. Put your pens down. Let's draw the first graph. Let's draw our axis from 0 to 360, right? Okay, yeah, watch. Pay attention, guys. So it's going to go up to 2 and down to -2, and that's 0, 90, 180, 270, 360. So the sine graph starts at 0. So here goes. Here's your sine graph, guys. Here's your sine graph. And your cos graph now is going to come from there down here. It's going to come down here. It's going to turn. It's going to cut. And it's going to stop. Right. So this is graph F. And that's graph G. Okay. Now let's answer this question. Now, f of x. Now the first thing we need to find out is obviously where the two graphs intersect, because there's an equal to. So where is f of x equal to g of x? So let's do that. Where is f of x equal to g of x? So that means where is 2 sine x equal to 2 cos x? Divide by 2, divide by 2. Divide by cos, divide by cos. So now, sin x over cos x is tan x. Cos x divided by cos x is 1. X is equal to 45 degrees. Shift tan 1 plus k times 180. General solution for 10. That means 45 degrees is the first point where they are equal. The other point, remember, this is 90. That's 180, that's 270, that's 360. Then this point here is going to be 135. Right? 1 times 180. Or you can go minus 1 times 180 minus 45. So that means 180, this is going to be 180 plus 1 times 180, 180 plus 45, that's going to be 225. That point there is going to be 225 degrees. Right. Now that we've established where the two graphs are equal, using general solution, now we can answer the next question. Where is f of x times g of x less than or equal to 0? Are you all with me? Onliners, are you with me on this? Are you with me on this? Do you know where I got this from? Do you know how I got this? They say they can't hear. Can you guys hear us? Or was that long time ago? Talk to us, onliners. Right, here we go. So now we're done with this. Let's go back and let's answer the question. Now, where is f of x times g of x? So now, f of x times g of x, or divided, less than or equal to 0. Less than or equal to 0 is negative. Now, what times what will give me a negative? A positive times a negative, that's solution 1. And then solution 2 would be a negative times a positive to give me a negative. Are you guys following me? Right, let's answer let's do solution 1. Let's do solution 1. Where is f positive? F is positive from 0 to 180. from 0 to 180. Where is G negative? G is negative from 90 to 270. From 90, so this is where F is positive. Where is G negative? From 90 to 270. Where do these two overlap? They overlap there. So 90 to 180. So your first answer is X less than or equal to 180, but greater than or equal to 90. That's your first solution. This is where they overlap. You can clearly see that's where they overlap. They don't overlap here and they don't overlap there. Make sense? Now let's do solution 2. Let's do solution 2. Where is F negative and where is G positive? Where is F negative? Where is F negative? The first one was where F was positive. Solution 2 is where F is negative and where G is positive. F is negative between 180 and 360. Where is G positive? G is positive from 0 to 90. From 0 to 90. So from 0 to 90. And it's also positive, graph G, from 270 to 360. Where do these two overlap? Do they overlap here? No. Do they overlap there? No. Where do they overlap? From 270 to 360. That's where they overlap. So X less than or equal to 360, but greater than or equal to 270. There we go. That's it. Make sense to you now? That's how you do it. That's how you do it. Let's go into Euclidean, guys. We don't have much time. I think we only got about 30 minutes. Let's go into Euclidean. Guys, by now you should know your theorems. I don't need to teach you. Please learn the following theorems. The proof. Number 1, you have to learn your 10-chord theorem. The other theorem, line drawn from center of circle. And the third proof, exterior angle at center equal to 2 times angle at circumference. So learn these 3 proofs. Now you, guys, you're going to get easy Euclidean, difficult Euclidean. The difficult you leave for last. Do the proof. Then do your easy circles. You leave the big circle, the big heavy one for last. You got time, you do it. You don't have time, make sure the rest of your paper you got 95% for. You'll still get an A for your paper. Okay. So you've got these 3 proofs. That's what you need to learn. Right. The first question that they give you, let's take that circle down. Right, let's go. O being the center of the circle. Then they give you a line going from there across there. That's a diameter. Then they give you a line going from here. Whoa. Okay. Then they give you a line going from here to here. Just give me a second. Just wait, just wait, just wait, just wait, just wait. Sorry. Super muff. Right, let's go again. They give you a line going from there. From here, going across there. Stops there. From here, going across here. Till there. From there, going right across there. Then you got a line parallel to this. There. Line parallel coming down there. Then you got a line coming down there. Line going across there. And you got a line coming from there down there. There we go. Okay, let's label the diagram. This is E. That line is parallel to that. O being the center of the circle. This is B, B1, B2, B3. You already can see here, guys. You can see already you got a cyclic quad. You know angle at center. Here's the spearhead shape. You know you've got alternate angles here. You've got angle at center is 2 times angle at circumference. So, I mean, this is a loaded question. O2, this angle is angle O2, and this angle here is 100 degrees. That's O1. That's F1, F2. This is 20 degrees. This is D1, D2, D1, D2, and that's A1, A2, A1, A2. Right. With reasons, they want angle A2, they want angle O1, they want angle F1, they want angle A1, they want angle B2. With reasons. Now, you always start with the known. What is the known? The 20 degrees or the 100 degrees? Is there a relationship between A2, what they want me to find, and this angle here, 100? Yes, there is. The spearhead shape. Angle at center is 2 times angle at circumference. So A2 is 50 degrees. And you will write exterior angle at center equal to 2 times angle at circumference. Easy? Easy. First, like 10 marks. One for giving your first 10 marks of your paper, guys. What is angle O1 equal to? Come on. Is there a relationship between what's given and O1? Yes, angles on a straight line add up to 180. So O1 is equal to 80 degrees. What's the reason? Adjacent supplementary. Angles on a straight line add up to 180 degrees. What's angle F1? F1, come on, we got O1. O1 was how much? 80. 80 plus 20 is 100. So F1 is also 80 degrees. Sum of angles of a triangle. This triangle here. Let's highlight it. Let's highlight it. We got a triangle there. That's 80. That's 20. 80 plus 20 is 100. F1 must be 80. Sum of angles of a triangle. Angle A1. What angle? This is C, right? Sorry about that. But anyway. Angle A1 We want angle A1. How much is angle A1 equal to? Come on, these two lines are parallel. If this angle here is 80 degrees, that means this whole angle here will also be 80 degrees. Corresponding. So we can say, to answer A1, we can say angle A1 plus A2 is equal to 80 degrees, because it's equal to F1. Equal to F1. Corresponding. Therefore, angle A1 is equal to 30 degrees, because 30 plus the 50 will give me the 80. Yes or no? And B2, where's B2? B2 is there. Alternate is equal to 30 degrees. Alternate angles. It's alternate to A1. Finish. 10 marks. 10 marks. Now just give me a second. Another paper here. Here we go. Now they're always going to give you a circle where you're going to have to use Pythagoras. So let's do one like that. So remember, you already got 6 marks for proving your 10 chord theorem. You got another 10 marks here. You got 16 marks. You got another 7 marks for this Pythagoras. So 17 plus 7 is how much? 24. Then you're going to have easy grade 11 work for another 10 to 12 marks. That will take you right up to 35, 36 marks. You'll have one last question, a heavy question. So you can still score your A. Right, let's do this one. Take this one down. Right, so they give you a circle. O is the center of the circle. They give us a straight line coming down there. No. Right, they give you a line coming across there. They give you a line coming across there. They give you a line. Yeah, that's it. That's it. That's it. That's where we stop. That's it. Let's go. Let's go. Let's go. Let's go. So we got P. That's point P. That's O. O is the center of the circle. They tell you this is 2x. They tell you this is 90 degrees. This is S. This is T. That is X. From there to there is X. From there to there is 2x. And this is R. Now, whenever you see a diagram like this, you know radii, Pythagoras. Radii, Pythagoras. That's the only 2 concepts you need to have in your head. And we know, although they didn't tell us, but we know line drawn from a center of a circle perpendicular to the chord bisects the chord. Yes or no? Yes or no? So this point here is U. So the first thing we can say without them even giving us, we can say, oh, US is equal to UR. Line drawn from center of circle. Perpendicular to the chord. Bisects the chord. Right. Let's see what's the question. In the diagram below, O is the center of the circle. SR equals 40. They tell us SR equals 40. Also given that UT equals X and OU. That's all that they give us. OT is perpendicular. SR is 40. Where's SR? SR equals 40. Okay. What's the question? Question number 1. They want OR in terms of X. The length of OR in terms of X. And question number 2, find the value of X. First question, question number 1, 2 marks, 5 marks. Total marks for this question, 7. Not difficult at all, I hope. Let's go. Let's see what they gave us. Come. Again, no memo, but we're going to get it right. SR is 40. SR is 40, so that must be 20, and that must be 20. So this is equal to US equals UR, which is equal to 20. So you can say that. Okay. All right. That part is 2x, that part is x. This whole thing here is a radius. So if that's a radius, that means this is also a radius from there to there. That's also a radius, which is equal to 2x plus 1x, which is 3x. Here we go. There we go. So we answered we want OR in terms of x. Finish. OR is equal to 3x. So let's, how would you answer that? You'd say, to answer question number 1, you'd say OT is equal to OR radii. OT, therefore, OT is 2x plus x is equal to OR. Therefore, OR is equal to 3x. Finish your first 2 marks. It's not writing. Just check. Nada. There's it. It came back. Just check. There we go. OT equals OR, which is radii. I'm just going to do that in a different color. And let's make that pen thicker. OT equals OR. That is 2x. That is x. These two sides are equal. So your radius is 3x. There we go. 3x. Okay, let's go back. Now let's say find the value of x. Now, what did I say? There's only 2 things. Pythagoras now. Where's your Pythagoras? Where is your Pythagoras? Your Pythagoras is here. In this triangle here. So now you write it out. Let's write it out. We say in triangle OUR or ORU. Right. We know that OR squared is equal to OU squared plus UR squared. Pythag. So OR squared is 3x all squared is equal to OU squared, which is 2x squared, plus UR squared. UR is 20 squared. Here we go. Let's get our next 5 or 6 marks. So that should be careful here. It's 9x squared is equal to 2 squared is 4x squared plus 400. So 9x squared minus 4x squared is equal to 400. 5x squared is equal to 400 x squared is equal to 400 divided by 5, 80. X is equal to the square root of 80. X is equal to, what's the square root of 80? 4 root 5. 4 root 5 units. Finish, and you'll get 5 to 6 marks for that. Okay, here comes another circle for another 4 and 2, which is 6, and 3 is 9. I'm just showing you how easy is it to get an A for Euclidean without even doing the difficult, heavy problem. So we had our 10 chord theorem, which was 6 marks. We had this problem, which was 2 and 5, which was 7 marks. Right? We had that other question that we did that was basic 2, 4, 6, 8, 10 marks for getting an angle and a reason. Where are we sitting on? 23. Now here's another 9. You're sitting with 32 out of 50. You're already sitting on 64% for this question. Oh, and there's another 2, 4, 6, 8 mark easy question. So what did I say? 23 plus 9 plus 8. 40. 40 out of 50, and we haven't even touched the difficult one that's going to hit you for 6. Leave that for last. You got time, do it. You don't have time, leave it. You'll still get 80%. You'll still get 80%. Watch the next question. We're going to do it together. Check here. 2, 4, 6, 8 marks. So here's your next 8 mark question. On your basic, I'm not talking about advanced. I'm talking about your basic. Here's your next 8 mark question. Come. Right, so O being the center of the circle, we got a line going straight across there. We got a line coming down here. There we go. We got a line going across there. We got a line going right up to the top from here to here. And we got a line coming from here to here. And you got a line from there to there. There we go. Right, let's label the diagram. This is another 8 marks. Honestly, you cannot afford to fail this. This is so easy. That's 51 degrees. That's U1. That's O1, O2. Please, whenever you have a center of a circle, radii always make isosceles triangles. Don't forget that. P1, P2, Q1, 17 degrees. Oh, they give us something there. And they give us a 51 there. And I guess that's it. Come on, how difficult can this be? In the diagram, O is the center of the circle. CPRU, OQR is 17, QRU is 51. Right. Calculate with reasons the sizes of. Same paper, eh? I'm not working, this is not 2 separate papers. So I'm showing you out of your 50 marks, how much 40 marks is basic. Only 10 is difficult. Leave the 10 for last. Find R1, find O1, find Q1, find U1 with reasons. What did I say? Start with the given, start with the known. You're either going to start with 17 or you're going to start with the 51. We want R1. So we want to get here. So let's see. We want to get to here. Let's do it in a different color. We want R1. That's where we want to get to. Okay. Where's the relationships here? Where are, now R1, now let me teach you something here. This one here is for 4 marks. Actually, that's 4. That's 2, that's 2, that's 2. 2, 4, 6, and 4, 10 marks. Okay. Now watch here. R1, what they want, is related to which angle? Is it related to the 51? No. Is it related to the 17? No. Which angle is R1 related to? Isn't it O1? Yes or no? Right, now ask the question. Is O1 directly related to 51? No. But O1 is related to O2. Is O2 related to 51? Yes. Angle at center is 2 times angle at circumference. You know the bow tie from the center of a circle? You remember if you had a circle and you got like a bow tie starting from the center of the circle, angle at center is 2 times angle at circumference. Yes or no? So that's our path. That's how we're going to get to R1. Right, so watch. So let's start here with the known. I can't start here. I'm going to start here. Although I started from R1 moving backwards. But now I start from R1 moving forwards. So R1, remember O2 is 2 times R1. So let's write it out. Right? I'm writing the answer out for you. Let's all write it out together. Right, we're answering question number 1. Angle O2 is equal to 2 times R1. Why? Angle at center is equal to 2 times angle at circumference. So O2 is equal to 2 times 51. O2 is equal to 2 times 51 is 102. So we got this angle here, angle O2 to be 102. So O1, therefore angle O1 is equal to 180 minus 102, adjacent supplementary. Angles on a straight line, which will give me how much? 78. So O1 is 78. Now, what's the relationship between O1 and R1? Therefore, angle at center is 2 times. So, therefore, angle R1 is equal to half of 78. Exterior angle at center. So, R1 is equal to 39 degrees. There we go. R1 is 39. Done. There's your first 4 marks. Are you all with me, SP learners? Relax, we got 6 minutes left. 6 months. Now we're going to do O1. The next one, O1. Come on, we've done it already. 78 degrees. Proven above. What is Q1? Now, if this is 78, what did I tell you? Radii always make what type of triangles? Isosceles triangles. So let's get Q1. But you got to write it out. So let's write it out. We're answering question number 3. We say, this is O, that's P. We're going to say OP equals OQ. OP equals OQ radii. Therefore, triangle OPQ is isosceles. Therefore, angle P2 is equal to Q1. Angle P2 is equal to Q1, which is angles opposite the equal sides. Angles opposite the equal sides of an isosceles triangle. Therefore, angle Q1 is equal to 180 degrees minus 78. And because these two are equal, we divide it by 2. Sum of angles of a triangle. Let's put the answer here. Q1 is equal to, this one, although they only issued you 2 marks for it, it could be a 3 or 4 mark question. So now 180 minus 78 equals, divided by 2 equals 51 degrees. 51 degrees. So Q1 is 51. That means P2 is also 51 degrees. Let's answer the last question, U1. U1 is related to which angle? Look at the big bow tie. Let's highlight this. Let's highlight this. Whoops. U1 is related to this entire angle, Q1 plus Q2. Yes or no? So let's go. We're now at the end. So angle U1 is equal to angle RQP. RQP. Why? What is the reason? Angles in the same segment. So U1 is equal to 51. We got 51 plus 17. U1 is equal to 68 degrees. Boys and girls, that brings us to the end of our session. Yeah. 2 days math boot camp. Onliners, did you survive it? Did you survive it? U1 is equal to 68. Well done, Lesedi.
So guys,
Well done, Gift. Well done, Precious.
you can keep you can keep on packing now, but please don't stand up with but Mr. Zamai, who will be giving us the final remarks. I can't find Mr. Baker. Oh, Mr.
There's
Baker
Mr.
is
Baker.
here. Okay,
Boys and
yes,
girls,
Mr.
thank you
Baker.
so much. Onliners, we love you lots. It's been an amazing 2 days with you. I can't believe we completed the entire paper 1, paper 2 with you. Good luck to all of you. Lots of love from myself, the Awqaf team. Just want to say Jazakallah to Mr. Baker, to Awqaf Department of Education, and mainly to say thank you to all of you. You guys have been absolutely amazing. One last round of applause for everybody, guys. Big shout out also to the maths teacher, Mr. Clement Ngoveni. This is from all the way to Shabangu. So big shout out. Lots of love. See you guys. Good luck. And let's just wait for the closing words from Mr. Baker. Mr. Baker, thank you so much.
Okay, just before my closing words, firstly, students, you've shown resilience. You've shown that perseverance for over the past 2 days, the resilience to be here for the 2 days. And that for me, you must see as a positive in terms of your preparation for your final exams. You have about 9 school days left. I think for most of the centers throughout the country, about 9 school days. You've got 1 more weekend. Please see that you use your time as effectively as possible. Cut down on the time that you spend on your cell phones, the WhatsApping, etc., and put all that time into ensuring that you are preparing for all your subjects. Just on behalf of the house school, as well as the students who have been online with you, Mr. Kota, just on behalf of all of us, we want to thank you for your efforts, and then to our MC also, the convener also of the program. Thank you very much to you for your efforts. I'm just going to allow Mr. Samai. He spent the day here. He's one of our maths teachers. I'm just going to ask him also just to say a few words.
To Mr. Kota and Awqaf, we'd like to thank you for sacrificing your time to ensure the success of learners around
Thank
the
you.
country. Thank you.
Thank you so much, sir.
And then we also want to just ask one of our students just to thank you also on behalf of the students who attended over the past 2 days.
Mr. Kota, on the behalf of the SP community, we just want to give much thanks, and we learned a lot, I must say, and it's going to be very useful in the upcoming exams, and I hope you enjoy further journeys, and thank you.
Thank you so much. Thank you so much. Absolutely amazing being here in Cape Town.
Mr. Kota comes all the way from Johannesburg, so we also wish him a safe trip home. Also,
you.
just by the way, students, there's also some physics that we have online.
No.
No physics.
We had the grade 12 physics last weekend. Okay, I wasn't hosting it, but it's part of the Awqaf program. But next weekend coming up, if you guys got siblings in grade 10, know that we're having it here in Cape Town at the Al-Azhar Institute. So grade 10 workshop next weekend. And yeah, I hope to see you guys at the end of the year and beginning in grade 12 and get the best results out of all the different schools. Thank you, Mr. Baker. I'd love to hear all of you. Good luck. May God be with you guys, and hope to see you guys and mentor you till the end of grade 12.
And next year, those of you who are going to do pure maths, and I'm sure it's going to be all of you, Mr. Kota will be available again next year for the grade 12 program. So thank you very much to everybody. Thank you, students. You may now leave and go enjoy some time.
In the year 2000, Awqaf South Africa was pioneered as an institute of Waqf and the empowerment of communities. South Africa faces a diverse set of challenges with a high unemployment rate and a stark divide between rich and poor, where electricity, hospital care and water shortages plague communities and where lack of education hinders progress. Awqaf South Africa is a catalyst for change. As a charitable endowment receiving organization, Awqaf invests endowment funds wisely and ensures that only the income generated from investments is used to fund a variety of community development projects. We are excelling in all that we do with the highest standards of ethics, integrity, and sincerity of purpose. From masjid development, imam empowerment to sports development, orphan support, food security, and surgery support, Awqaf South Africa is paving the way by investing in the future of communities and uplifting generations to come. Awqaf South Africa, creating a legacy of hope and